Hey everybody, welcome to the Friday 3D Printing Community Hangout. This week uh, we have Proto-Pasta, we have Alex from Proto-Pasta, and we have Keith, or otherwise known as Tinkers on Twitter. And we also have Sean from IC3D Filament, IC3D Printers, um, both of which are filament manufacturers here in the United States. And they came on tonight to talk about the filament manufacturing process, things they've learned along the way, and the different products that they offer, as well as get to answer questions from those of us on the panel and those of you in the chat. So as the stream goes on tonight, if you have questions, post them in the chat. I'll be paying attention to the chat, as will the other co-hosts, and we'll try to get as many questions answered as we can within this first 2-hour mark of the stream. So let's go ahead with introductions, and we'll start with Dave Randolph.
Hey, it's David Randolph over at Printed Solid. Find us all over on the social media, Printed Solid on Twitter and Instagram and Facebook and all the other fun stuff, so everyone knows where we are. And yeah, it should be fun, and we'll have a good time tonight. And I'll tell you about our events and all our fun stuff later.
Okay, Richard. I'm not sure if he can hear.
Okay, no, I'm just fighting with my system there. My name's Richard Murray. I have the ZDIM channel, and I try to focus on 3D printing for model trains, but lately I've been caught up in the world of gaming tiles. So the easiest way to find me is ZDIM.com. You can see the address down here. I'm ZDIM17 on social media, and I try to go live every Wednesday at 4 p.m. Pacific.
All right. And next we've got Alex from Proto-Pasta.
Hey. Can you hear me?
Yep, you're good.
All right, cool. Figuring out this fancy technology. I don't get to hang out nearly as much as I'd like to on such things like this, but I'm Alex from Proto-Pasta. I got my start in the industry in the industrial side like almost 15 years ago, and I really enjoy the community aspect of things, and been really embracing that the last 5 years as part of Proto-Pasta. And you can find us on Instagram and Twitter, and our website's proto-pasta.com.
Alex's voice is cutting in and out tonight, but that's his internet connection.
Right, yeah. Not me losing my voice. I'm not worried at all about having to talk all day tomorrow at a filament workshop.
Is all your spots for the filament workshop taken now? Are you guys all booked up?
We are, yeah. We've got twice as many as we had with our first one in the summer. So we've also got twice the staff. It's a new adventure. Yeah. Awesome. Should be fun.
All right. And next we've got Tinkers, or Keith from Proto-Pasta.
All right. I'm hoping everybody can hear me because I'm just audio only as I'm driving. So no distracted driving, just on the Bluetooth here. And so I'm Keith, better known as Tinkers on Twitter. I work at Proto-Pasta. I'm your support guy and a few other things. I kind of hide behind the scenes there, I think, most of the time. Anyways, and yeah, that's all I got.
All right. Next up, we've got Sean.
What's up, everybody? I'm Sean. I work at IC3D Printers. I am an extrusion operator and also run their community stuff and handle emails and customer support as well. And so I've been doing that for almost a year now. And yeah, you can find us at IC3Dprinters.com and check out all of our stuff. We have a print shop, a full industrial additive manufacturing print shop that we are expanding recently. It's starting right now. So it's kind of crazy in the shop. And then by Murph, we should have a whole new print shop built. And then we have extrusion lines where we make filament. That's that.
So that's everybody we've got on tonight so far. If anybody joins in the middle of the stream, we'll go ahead and give them a chance to introduce themselves. So for everybody who watched the multi-material episode that we did back in late August, early September, we had the two guest companies that came on. We gave them a chance to talk about their products, and I'd like to do that again tonight. It's not going to be as long. Last time it was about an hour for each company, but they were talking specifically their multi-material process. I'd like to give each Proto-Pasta and Sean from IC3D, give them guys a chance to rep their products as a thank you for them coming onto the stream. So let's go ahead and start with Alex. Go ahead and tell us about the products that Proto-Pasta makes.
Okay, right on. Well, Proto-Pasta makes filament. The name is because filament looks like a noodle. So a combination of Proto-Plant, which is our company name, and the shape of the filament. So don't eat the pasta.
And you guys make a HTPLA. Do you guys do regular PLA at all, or just the HTPLAs?
We have a couple of our classic, like original composites are based on just a more standard PLA. The carbon fiber, the stainless steel, and the iron, and the conductive.
Okay.
Everything else that's not PCABS is HTPLA. Basically, the two grades, one more readily crystallizes and better survives the crystallizing or heat treating, annealing, whatever you want to call it, process. And when we kickstarted 5 years ago this month, actually, we introduced 3 new materials, one of which was carbon fiber PLA. I'm pretty sure there wasn't a carbon fiber on the market until then. Now, obviously, it's much more commonplace. We had our PCABS, which is more of an engineering material. And our original focus was really around like engineering, bringing engineering materials to the masses, because 5 years ago it was basically like Stratasys and the materials that were on their systems, but the greater like marketplace didn't have options. And the third material we brought on board was our first version of HTPLA, and we since discontinued that. It was opaque. And we now have, a clear base that we start with, so we can leverage that for more transparent HTPLA filaments. When you do heat treat it, it does turn opaque in the heat treating process. So if it's not an already like opaque version of a color, then it's going to end up being opaque if you want the higher heat properties. And we ended up just kind of getting behind that, because we do have both an interest in like the aesthetic and the engineering, like functional usefulness of things. So the HTPLA, though plenty of people don't leverage it, it's a really cool feature that makes the material way more useful than just a standard PLA. I actually can't hear you.
Sorry. Helps if I unmute myself.
Okay, sweet. I was like, did I screw something up on my phone again?
You were concentrating so hard, I thought you could hear me.
Working on it.
The HTPLAs, you're at V3, right? There isn't a V4 yet.
There's no V4, and V3 is not like obsoleting V2. It's sort of an evolution. So the V2 is a very, very pure like form, and it's translucent. And then the V3, we add some elastomer, which makes it opaque, and it also just takes that like brittle edge off the PLA, gives it just a little bit more forgiveness, which is nice because we still retain most of that stiffness and strength of the PLA. which if you get, I mean, there's a wide range of what folks call PLA, but there's a lot softer grades where you lose some, you give up stiffness and strength in some of those grades, and we wanted to maintain most of that.
Okay.
And then that V3 does, the elastomer in it is hydrophobic, so it's a little nuanced, but it just further like keeps the material more dry and like higher performing.
All right. And you guys have, so as far as your line goes, you have the matte fibers, which give you a nice matte finish instead of the traditional shiny finish from PLA. You have your metallic composites, or not all the composites are, like the copper and stuff is HDPLA, like you said, carbon fiber, conductive, and I think there were some others that you had said.
Yeah, steel and iron are still all PLA. We do have also a high temp grade of carbon fiber, or the HTPLA grade. And that's nice because the carbon fibers mitigate the shrinkage in the heat treating process. And it's a really, I mean, gives you a really stiff, high temperature result. I mean, you can retain a useful amount of stiffness up towards like 160 Celsius. So where something like a more amorphous PETG material is going to lose almost all its stiffness in like 70 some degrees Celsius. So you're almost gaining like 100 degrees of usefulness even over PETG, which is I think not all that well understood, and we haven't communicated all that well either. I think some more product demonstration, application demonstration could be beneficial to understanding just how useful that feature is.
That is something that I personally, I've got a bunch of the HTPLAs, and it's something I have not done yet, is tried to heat treat any of it. I keep printing stuff out going, oh, I'm gonna test this, and then I just never get around to it. I use it for whatever I printed it for, and that's that. But that is something I want to play with, and like comparing like the shrinkages and everything to it, because I've seen, years back, and I think that was on V1 of the HTPLA, people doing shrinkage comparisons and stuff. But I haven't really seen too many people showcase the newer stuff, and the newer stuff shrinks less than the old stuff does, right?
Yeah, the V3 is going to shrink less than the V2, but carbon fiber still shrinks the least.
Yeah.
So, if you want really a more like mechanically accurate part, you're going to lean towards the carbon fiber version. The thing that we've done is made, so many of the HTPLAs just aesthetically beautiful, so you can enjoy them as is. But if you want to turn that into something more than a sit in your office kind of part, you have that opportunity. And especially if it's a more aesthetic part anyway, and the fit isn't important, then and even a little distortion in something that's very freeform or sculptural like, you just don't really have to worry about it. You can just sort of like harden the part via heat treating and move forward. Now,
Right.
you've got interfaces that are like, the accuracy is really important. You may have to fixture to like avoid distortion. You may have to oversize to compensate for shrink. You could always, on some of the composites, do a post machining if that's useful or interesting. We've definitely been surprised how folks have applied the HTPLA once it clicks for them. Making some like on-engine car parts and stuff that you're like, wait, PLA, what? But they've pushed it to a few folks have pushed it to the boundaries, and plenty of other folks don't understand well enough where it can be pushed. So yeah, there's a lot of it makes the product more complex but more interesting, and there's a lot of opportunity to dig in and get to know it what's possible quite a bit more.
Cool. All right.
But you can also just enjoy it as is, right? Because like the beautiful metallic finishes, and so you don't have to, if you want to just not get deep with it, that's fine too.
I will admit, most of my Proto-Pasta purchases are enacted by my wife. The moment you guys release a new collar, she's like, I want that. So I end up printing something for her for work to take and put on her desk or whatever the case may be. All right.
Awesome. That's cool, because part of what we aspire to is, with the combination of colors and finishes, is broader appeal as well. That sort of crosses boundaries. So that's cool.
All right, thanks, Alex. Let's jump over to Sean from IC3D and let him talk about the products that IC3D offers.
Awesome.
What's up? So yeah, we make plastic. Can you hear me? Can everybody hear me and see me?
Yep, you're good.
Okay, cool. So so we make plastics. And first thing I just want to say is I totally agree with Alex 100% that you can push this as far as you can push it. I mean, you can push it past the limits. Like there's so much stuff that you can do with plastics, and it's just unbelievable with the different additives and different processes to make it. As for us, we're geared towards more geared towards engineering and industrial use, so an ease of use for the user, for big machines, for additive manufacturing, and not so much. I don't know. We haven't really dove into a lot of crazy stuff yet, and not saying that we're not going to, but as of right now, we're working on pretty much making the materials and making the best versions of that material without using additives yet. With that said, we make ABS, PLA, and PETG now, and it's all open sourced. The ABS was open sourced first when the company first started, and then just this year, actually at EARF, the first night at EARF, we got approved as open source for PLA and PETG. So that was a big thing, and it was cool that it happened at EARF. So that was pretty neat. On top of that, you know, we do our printing service, but this is about filament, so I'll stick to filament. Yeah, it's just it's a process. I mean, I don't know what you want to know. Like, ask me questions, and I'll answer questions.
You can go ahead, Sean, if you want to take a minute and just go ahead and rep everything that IC3D does have to offer, because I know you guys do more than just filament. Go for it.
Okay. So we do produce our own filament. We produce around 300 pounds a day of plastic, and then we use most of that, or majority of that, for our print shop and print services, which we have. Well, right now we have we have about 14 desktops, 4 mid-range printers, which are 600 by 600 by 600. And then we have one 1K cubed. And then now we're building 6 6-foot machines, or 4 6-foot machines. And then one machine that has 4 heads that prints all at one time on one bed. So we're amping up, and then we're going to be getting more desktops as well. So things are starting to pick up, and so yeah, that's print shop. We also do engineering, consultant stuff. We are working on some other things right now that I shouldn't mention yet until it happens. But
where are you located?
Sorry?
Where are you located?
Thank you. We are located in beautiful cow country, Columbus, Ohio. So if you all want to come down and check us out, please do. We have open tours, and it's a lot of fun. Come hang out and see the print shop, see how filament's made. Yeah.
Sean, how many extrusion lines do you guys run on your filament process?
We run 2 right now.
Is that it? 2? Okay, I thought you guys had more.
Nope. we run 2 right now.
And Alex, how many do you guys run? 3. How many?
I thought you had like 50.
How many pounds of
marketing?
How many pounds or kilograms of filament a day do you guys produce, Alex?
My hands I'm not on the pulse of that right now, but like around not much different than Sean, to be honest.
Right around 300 pounds.
200 to 300. Yeah, we're pretty specialty niche, so we're not big on volume.
Yeah. Sean, back back to you and the products you guys offer. You offer various size spools. Like Proto-Pasta has the 500 spools. What size spools do you guys offer?
So we have, and I have no clue why we run in pounds, but we run in pounds. So bear with me. So we have a 2 pound, which is 1 kilogram. We have a 5 pound, which is 5 kilogram or somewhere in there. And then we have a 10 pound, or a 22 pound, which is
10 kilograms.
10 kilograms. So we have 3 different sizes in every material.
Hey, if you have not been to Murph or Earth and seen one of these IC3D 10 kilogram spools, they are freaking ginormous. Sean, you asked that.
Can I say, just in contrast, the biggest we do is 3 kilograms. So
you guys do kilogram spools. Okay.
Yeah.
I didn't know that.
Just for reference.
On cardboard spools?
The 3Ks are on plastic. Not so much. 1K, we do have 1K cardboard though.
Do you?
Yeah.
Awesome.
There was a question in the chat. Oh, Sean, you said that right now you guys are doing straight runs of filament. PLA, PETG, and ABS just with collarants in them. Chris asked in the chat what you're looking to do next in your filament testing and what you're hoping to achieve. Any plans for additives and stuff?
Hold on.
Well, we don't have
my little tiger, a little lion, little baby. So right now we are, yes, I'm rocking them. Don't judge. So right now we are doing. We're trying to get out there more and do more things. Right now, I'm trying to work on matte filaments. Is my main thing, and I'm working with chemicals right now to make the matte, and different additives to make it matte. Not so much anything that has to do with fibers or anything, but just a straight matte filament. And it's actually pretty tough. I'm having a hard time doing that, but so hopefully that will be coming out soon, within the next year. Other than that, it's just making fun colors and seeing if people like them, and seeing where we can take colors and how we can, mix and blend and get a nice unique color going.
Okay. Anything else you have for IC3D? Kind of just what you guys do, what you offer for products?
For products, we offer ABS, PETG, and PLA. We do also offer Hytrel by DuPont, which is a flexible material, but it was originally made for injection molding, and they just made it into filament now. And we have done products for some automotive companies with it, and the results that have came from it are just off the wall. Like, you can use it for production model stuff. It's real good. So DuPont, look into that, DuPont Hytrel. It's some real good stuff. And then also we sell X-Strand, and that is glass-filled nylon. So coming out of France.
All right.
So that's what we offer for filament.
Chris Riley in the chat, and I think this question is open to both of you guys. It wants to know how many of your filament lines speak English. Alex, go for it.
Well, yeah. Okay. Well, our mixing, our compounding extruder does speak German, because it is a German machine. It's a Leistritz. So, and our machines all do have different voices and talk to us as we're making things. Because I don't know. Because all our machines are all like home brewed by us. I mean, they're made by us. And so they've got like our quirky sense of humor with the way that they work.
Sean, do your lines speak at IC3D, or is that just a Proto-Pasta thing?
You know what? They try to speak, and I just make them stop. Honestly, sometimes they tell me to shut up. So, yeah, they speak English. One actually speaks binary, and then the other one speaks speaks Chinese and English.
It speaks binary. So does it beep at you, or does it say 01100?
Sometimes it's just all zeros, and I have no clue what to do. Yeah, so one is actually a manual use. So you have to do everything manually, like back in the 70s.
Like hand crank the filament out the other end, or
you gotta get the gerbils up in the wheel. Turn the screw. So one, you have to actually adjust everything by knobs and dials and set the temperature manually by hand, and then go set the polar manually by hand and all that. And then our newer line is all automated. And that line is getting upgraded and upgraded and upgraded. And that's kind of like what we're trying to focus on. We're focusing on filament mostly, but we're focusing on what is the easiest way to make this machine, to make our lives easier. Like, how can we get this machine to practically run itself before I even walk in the door? You know, so that's where we're trying to get to. And as for speaking, one speaks too much and one doesn't speak enough. So.
Okay, Alex, do you want to run through the process that you guys have come up with at Proto-Pasta? Like, what's some of the things you said you guys have been established now for 5 years since the Kickstarter? What kind of things have you learned, quirks along the way about the filament making process? I mean, I think for the most part, everybody understands it. Filament starts out as pellets. You dump them into a hopper. It chews them up and forces them through basically a giant version of the hot end that our 3D printers have. It comes out close to 1.75 or close to 3 millimeter. And as it's cooled, it's stretched to get that final dimension. That's basically the process, right?
Well, I don't have anything to say now.
What's some of the things you've
Way to go.
Thanks for conserving my voice. No. I mean, we knew nothing about plastic extrusion when we started. And we didn't just go out and buy a machine to learn about it. We decided that we wanted to make a machine from scratch to learn about it. And it's just like I mean, starting the brand is just as much about making filament as like the interest in like making machinery. And our team, like, we're born out of an engineering services firm, and my two other partners in the business, they are brothers, and they've just been like taking things apart and making things like electromechanical things their whole life. So the Kickstarter was about bringing three materials to market. It was also about like following this passion for like figuring out how things work and creating machinery. So everything from our like production queuing, like software, which talks to our inventory, which talks to like the machines and what profiles for what materials, like it's all getting increasingly interconnected, and that's all homemade in the way that works. And just like continuing to work on those things is a big part of what my team is just interested in doing, in, you know, keeping busy and having things to do. My interest really came in with the colors, and having equipment in which, you know, other people have made to like leverage and create this, you know, these set of colors and finishes. So my background is more like application engineering and Yeah, I also, from the 3D printing standpoint, I don't really like to make printers, but I like to use ones that work well, and make beautiful things. So, and I don't mind getting into the guts of like some parameters and such, but like there's nothing more frustrating to me than like having shitty hardware. Excuse me.
So you guys, Proto-Pasta is sort of along the lines.
Sorry, I didn't really answer your question at all. Actually, I realized. My bad.
Oh, that's all right. I
How filament's made. Ramble.
I'll tell you what. Go ahead. What's some of the most interesting things that you've learned along the way? Oh,
Yeah. Well, we learned that it's a lot harder than you think. There's definitely an art to it. Trying, at least trying to get to the parameters that matter, or the conditions that matter, can be challenging. But let's see. Well, we learned you shouldn't dump metal powder and unmelted pellets together into a single screw extruder to try to make composite filament. That can be done, but the length of time in which you can maintain the process to get good filament is really dodgy. The process window is like super tiny. So breaking up your mixing process to get first a good mix, and separately your filament making to get good filament into 2 steps, was a big breakthrough when we were doing metal composites, for example. Yeah.
How'd you guys come up with the percentages? Because I know like there's what is it, Virtual Foundry, I think, where they're like a super high metal content that can be forged out, that the plastic can be basically melted out, and you're left with basically a metal part. You guys aren't anywhere near that percentage.
No.
How'd you end up along the way choosing the percentage of metal fill that you use in your composite?
Well, I mean, when we first started, it was like, what could we get a stable process in when we did our first metals? And then from there, I mean, some folks take the approach, or like they want to market like, hey, I put, more than somebody else in more additive in my material than somebody else. And I was like, well, I just want to find like the right balance. And so for our metal materials, we found what we think is a good balance of the ability to finish the material afterwards, and like a good, strong enough filament and good printing experience. You could put more metal in. We've done that, but we feel like it doesn't really add to the experience.
The more you add, it makes it more brittle, correct?
Makes it more brittle, yeah, more challenging to process. And then you get, since we all buy filament by weight, then you get less length too. So I think even versus the color fab metals, ours are quite a bit less dense. They're still like twice as dense as PLA, but you get, for the same weight, more material.
Okay.
So
sorry, I kind of interrupted you with that question. Interrupted a question with a question. So
whatever, we're just hanging.
What's some other things that you guys have learned along the way that you didn't expect to come across? Some of the challenges that you've faced, and maybe if you're open to saying how you fixed them, because I think for the most part everybody understands the process that it goes through.
Yeah. I mean, we choose to extrude the plastic without the use of water. So that introduces its own set of challenges, for example. And when we started, well, if you look back at the original Kickstarter video, we were catching filament with like basically an upside down sanding belt. We quickly, and then wrapping it around a flower pot upside down. So we've come a long way. But when we moved from the sanding belt, we had these 2 counter-rotating wheels that would like build up plastic, or like fume condensed fumes on the wheels, and you'd have to like scrub them like with a Dremel while it was still running, and it was really like we made it more complicated than we needed to, and it took all and it was really challenging when we started. Basically, like one of us had the knack to run filament, and between over the last 5 years, we've grown to have the machines and the I don't know, we've grown to have like an organization be able to make filament, not just like one person, and that's been like our goal to be able to make it more straightforward, more reliable, and more able to engage like number of people. Get out of that operator sort of like knack area and get more towards like a reliable, shareable process. What are some other things we've done in that? Winding, to be honest, is one of our bigger challenges. To get a perfect wind is, especially with a stiff filament like carbon fiber, it's a bit, well, it still actually eludes us a bit. So 285 carbon fiber does not really want to wind as nicely as we'd like it to. It's just kind of wants to go its own way because it's so stiff, and that it's tricky to wrangle. What other things have we done? We started with standalone extruders where you changed all the settings like on the unit itself, and we moved towards software run extruders, and then we revved again, and it has both, like where you can change the parameters at the extruder itself, or you can do the work of the software. But it's they're talking to each other, and we've done a lot of work to like have profiles and increase traceability for knowing like what was done for a specific batch of filament, and that was something that we didn't. 5 years ago, we weren't thinking about at all. It was just like some dudes trying to like creatively make something work. And we're, trying to, I mean, we're elevating what we do professionally as we go. Did I get, how far off topic did I get that time?
Yeah, you're good. You're good. Sean, what about you guys for IC3D? What's some of the challenges that you guys have faced along the way? I'm sure probably making consistent base plastics is a lot easier than doing the composites and things like that. But I'm sure there's probably some interesting issues that you guys have faced along the way.
Yeah. Well, I can't really speak much for composites because I personally have never done them. So I don't know if it's easier, if it's not easier, if it's the same, because you're adding a process to that. So obviously there's more work involved. There's more mechanics and thinking and more things that can go wrong involved. Another machine to break down pretty much, and that's actually one of the biggest problems we've faced is machines breaking down and trying to figure out why did it break down? What did we do wrong? What's happening? And that, I mean, and I think that was just a common thing when everyone started like, hey, I want to make filament. Let's make filament. And then you're trying to figure it out and nobody knows what the heck they're doing. And then finally you figure it out and you're like, I need to write that down. And then you make filament. But each material is different. Something I learned is, going through the process, it's PLA extrudes different than ABS. ABS extrudes different than polycarb. Polycarb extrudes different than PETG. And you have to make sure all your settings are correct, and we use a water bath as opposed to Proto-Pasta, which doesn't use a water bath. And water baths are super, super tricky because now you're adding another element into the mix. You're adding water, you're adding, what's the angle, what angle do you need that filament or that molten plastic to come out of the die and hit the water to create a solid, solidify. And then is it, is it solidifying the center first or the outside? And which is better? Is it better to solidify the inside or the outside first? Or does it just screw the whole thing up and just not do anything and then start coiling in the water? So that's always an issue, or that was an issue. And that is something that we have all overcome and is now a learned science. We've learned it, we've written it down, and we also have created profiles for each color, for each filament, for each diameter, and exactly how it's supposed to run. And it runs well once we figured it all out. The most recent was PET G, which took quite a while to figure out. And so pretty much for PET G, PET G is PET, I guess, poly composite. Yeah, I'm losing my words. I'm nervous, guys. Leave me alone. On the spot here. So yeah, so that's a I guess it's a composite, but it's not really like a composite. So it's a poly blend. And in order for that to run, you need to have a water cooled neck, and you're supposed to have a certain screw for each material. And I don't know anybody who does. Do you guys, Alex, do you guys have special screws per material? No, we don't either. Nope. We actually just ordered one for PET G. And so we're going to test it out, and we're going to try it and see if it was worth it or not. So,
see, my experience has been that it runs very similar to PLA, but I don't, yeah.
Yeah, I don't, kind of, not really. I don't know. It's weird. The temps. So if any of you knows or know, I kind of want to explain how our extrusion machines work. And it's kind of the same for all, but it's the same basis. So is that okay, Matt, if I go through that real quick?
Absolutely, yeah.
All right, cool. So pretty much you start with the host, which is in the back, which is the motor that drives the screw. The host, it spins and creates pressure, and the pressure builds up in the machine to kind of like melt the material and heat up the material. But that's also combined with several heating elements that is through the machine. And then you have the feed throat, which is in front, which is underneath, that the hopper sits on top, that needs to be cooled in order for material not to jam up on the screw. So the screw is coming through, and then the feed throat's here. The host is back here, and then you have the throat, or the neck, which the screw runs through with several heating elements. And our machines have 7 heating elements on them. So 7 different chambers going all the way across the screw. And then as the screw turns, it creates friction, which also creates heat. And you have to balance all the heat in all the different chambers in order for the material to melt properly and come out the die, which is at the end. But before it comes out the die, it has to go through the pump, which is like a set of gears, and it spins, and the gears mesh together and actually push that filament, that molten plastic, through and out to the breaker plate. And the breaker plate is it is a lot of information. So the breaker plate's here. The gears push it through the breaker plate, which actually puts it into cylindrical forms coming out, which also pushes it through our mesh blocks. So it collects all the nasty stuff that comes out. Anything that comes through, it collects on the mesh, which is like 3 or 4 different grades, depending on the plastic. And then it comes through that, and then out the die. And then we have like several different dies we swap all the time, depending on the plastic. And then from that, it goes into the water bath and out the other end.
The meshes that you're talking about.
Sorry?
The meshes that you're talking about. The 3 different mesh that it goes through.
Yeah, so there's 40, which is the 40 is a 40% mesh, and then it goes through it's a 60, 40, 60, and then it goes through a 40 again, and then out through the majigger, the breaker plate.
with water flow, there's laminar water flow and non-laminar. Is that sort of what those meshes are for, is to create a solid stream coming out, not only to filter any particulates that got in there that don't belong in it, but is that also acting the same way? Because what you described there is the exact same way. Like if you watch any YouTube videos on making laminar flow water nozzles, that's basically what they're doing. They're passing water through a bunch of straws or a bunch of fine tubes. In like the YouTube videos, you see people using a bunch of drinking straws inside of a piece of PVC pipe, but then they pass it through mesh screens of different sizes. Is that also the part of the point of that, to create the same? I don't know if it would be referred to as the same as laminar flow and non-laminar.
That's what the breaker plate does. The breaker plate is a round disc. I don't know. Let's just use here. This is a good example. It's a round disc with a bunch of holes through it. This obviously isn't a breaker plate, but you know, you get the idea. So it is a round disc with a bunch of holes that go through it. And behind that, behind the breaker plate, is going to be your mesh that catches all the crud that the plastic pulls off. Because when you're running different plastics, it catches on little things inside of it. That's why you need to purge. It's like that video I put on Twitter. Like that was purging. That was getting all that nasty crap out. That's why all that plastic, that natural plastic that was in there, was turning brown and just nasty, and chunks of
speckles in it and everything.
Speckles and crud and poo. Yeah, it's pretty nasty.
Was that because of different temperature materials?
Yes.
Yeah.
Yep.
Okay. Go ahead. Sorry, I didn't know if you had more.
No. So I guess one thing I learned is how the damn machine works. And then you know how to make it work, you know, how to continue to make it work. And it is a lot harder than you can say, oh yeah, you put it in the hopper, it pushes out the other side, and it goes through here, and then it comes out, and then it goes over some PC fans, and then onto a little spooler, and some guy's on the other end cranking it. And
well, you didn't like my quick rundown on how they work?
Yeah. But I mean, like, I mean, because before I started doing it, I'm like, how hard can it be? And I'm over here like, oh my God, what's happening? Oh my gosh. Like it's a lot of work. You're controlling temperatures, you're controlling pressure, and pressure is the hard part to control because it just wants to build pressure, and then eventually it's just going to blow out the front, and then someone's going to die. So it's you got to keep the pressure stable and everything stable, and so that's something, you know, that's the biggest thing I learned is keeping the machine stable and keeping calm when something goes wrong.
You made the comment, Alex, you did too, that you guys have your profiles or recipes for different materials, different, in Proto-Pasta's case, different mixtures. You have recipes that you go through. It was kind of funny listening to you guys explain that, because in an overly simplified, and I realize this is way overly simplified, what you guys do is very similar to what we end up doing then with the filament. In the end, we get a roll of filament, you tweak your settings, you find that profile and save those settings for either that brand or that type of material. Like in Proto-Pasta's case, you've got matte fiber HTPLAs, you've got metal composite HTPLAs. You have different profiles for those different mixtures. Right. But it, in an overly complicated way compared to what we have to deal with as an end user, basically is what you guys do in the filament process. You have a profile. When you're going to run a batch of this material, you dial it into these settings. And is it that simple? You dial it into these settings, and if you hit those settings right every time, it'll be consistent, or do you still have variations in it?
Yeah, I was gonna make a comment earlier but I didn't want to interrupt Sean. Just like you get things figured out and they are steady for a while, but then you're always surprised by something unexpected. I mean, it's not all. We should probably better monitor and know what the atmosphere, what the temperature is for the day, or the humidity in the air, or and like try to keep tabs on all the sort of external, taken for granted things. I mean, one thing that we've learned too, kind of back to the earlier question, is like you don't want to heat soak it either. Just like your hot end, you heat soak too long and then you jam, and then getting back out of that can be a real pain in the neck. In fact, it's a lot easier on a printer than it is on an extruder.
You spend a day and a half, trying to pull the screw out and everything, and then clean it all out, and then just to find out, it's like, oh man, well, I guess it jammed like all the way in the back by the feed throat. And you're like, they got to pull a whole screw out and clean it all out and then put it all back. And those screws are heavy. I mean, and hot. They got to be super hot to clean them.
How long are the screws? Roughly. A foot long, 2 foot. How long is the screw part of the
They're all different. You guys have smaller extruders than us, Alex.
Yeah, so our diameter of our screw is I think 3/4 of an inch.
Okay.
Don't quote me on that for sure, but the length is something like a meter or something.
Ours is like, I guess I don't know the exact diameter, but it's like a Coke can. Like it's big. And it's super long. It's, I don't know, 4.5 feet, maybe.
I'm assuming the different lengths probably change the rate at which you can produce filament, the speed that you can.
I wouldn't say that. I wouldn't say the speed that you can produce filament, because that's all based on the host and the pump. Or, I don't know. Do you guys have a pump, Alex?
Well, first off, I wasn't familiar with the term host.
The host is
just the motor.
The motor in the back that controls the pressure and the rate of the screw.
Right. Yeah. And so, and the other bit that you said that isn't familiar to me is like the gear pump in the front. We don't have any kind of extra pump.
Okay. That's how our machines are set up.
Right.
That's not like a normal. Yeah. So that's what I was asking. I was like, do you guys have that stuff? Because I know we do, but does anybody else? Like, are we?
Right. Like, and people are so quick to share what their stuff is. Sarcastically. Yeah, a lot of people like won't tell you. So, but but getting that right balance of like speed and heat, and I mean it's really again, just like your printer, you want to keep moving because it's about introducing energy at like a steady rate of like mass. You want a steady mass flow in which there's a steady introduction of heat for a steady rate of the screw turning. And it actually kind of leads me, not to get totally on the printer subject, but I think a lot of folks do themselves a disservice in settings with wide changes in speed in their printer profiles and create jamming because they're drastically changing the mass flow rate without changing temperature.
Right.
Which is just like asking for trouble.
Yep.
I can't imagine running an extruder to make filament the same way that a lot of people will end up running their printer with profiles. You would not get consistent filament.
The faster you make filament, the worse filament you're going to make. I mean, that's what I've run into. If you try to make it fast, you're not going to make good stuff. If you take your time and let it do its thing, you're going to make good stuff.
But you could also go too slow and end up with too much heat in your feed throat.
I'm not saying go like, I'm not saying run it at like 6% speed, but like, I mean, you got to find that balance between, am I going too fast or am I going too slow? If I'm jamming a lot, it could be either. Like, you're
Yeah,
right.
and it's the same on a printer, right? I feel like
Exactly.
What is a rough speed that you're extruding at? Okay, so 3D printing, everybody who's watching this is familiar with millimeters per second or millimeters per minute. What is the extrusion rate? And I'm sure it changes depending on what material you're doing, but like kind of a range. How fast can you produce filament?
obviously it's going to depend on density, but for like PLA like density, we're at typically like 5 to 7 kilograms an hour. So which is pretty small time. I mean, it's not desktop extruder, but it's yeah. So our approach is to have these increasing number of like small agile printers or sorry, extruders, where we can do a high mix environment of different materials. So if you get a much higher output machine, you want to be doing a lot more of the same material before switching out, would be my impression, if you wanted to have a good experience. So
So you said you're at roughly 5 to 7 kilograms per hour, you said?
yeah, PLA density. Yeah.
Sean, where do you guys stand?
It depends on the material. Honestly, the material and diameter.
Yes.
So our PET G, I can pump out on one machine. I can pump out 20 kilograms an hour. In 3 mil, and then a little bit longer for 175. And then ABS is like, I don't know, 30 kilograms an hour, and then PLA is a lot slower. So it's, I mean, probably 30 kilograms an hour. So.
Okay.
Part of that's going to be to do with having a bigger extruder, but you can also take a lot more heat out with your water. We have to not go too fast with the air cooling that we do.
Right, exactly.
How long is the air gap that you guys run, Alex? Your cooling gap, I guess.
Yeah, the length we run is something like 15 or 20 feet, maybe, to cool the filament. Okay. So we definitely like, there's even in our smaller extruders, there's more, we could go faster as far as pushing plastic out, but we're not going to end up at the quality that we'd want as far as cooling goes. And we've talked about like, do we pursue like longer lines or water cooling or something, but it just hasn't been important enough.
Real quick before we continue, I want to give Joe Mike a chance to introduce himself. Now he's jumping because we're drawing attention to him.
No, I'm just listening and watching.
Listening and watching.
Yeah. I'm Joe Mike. I just wanted to come in and say hi to everybody. Hi, Alex. Hi, Sean. Hi, guys. How are you? Yeah, the filament extrusion is one of those things that I've been like, it's one of those things that's secretly an obsession of mine. Like when the Filextruder came out, and I was like looking at that going, okay, is that something that's like viable? Can I like set that up in my basement and make my own filament? And then the more that I started talking to people who actually make filament for a living, I was like, yeah, I'm not gonna spend money on that.
Like, I want no part of that.
the maintenance versus the quality. I'll leave it to the professionals, but it's still amazing just to hear you guys talk about the amount of tuning and, dare I say, love that you put into the way you guys make your filament. I mean, it's I think so often we're used to printing Chinese stuff, so we don't get to hear very often from the people who are rolling it off the line. But I mean, obviously, we've got two American companies who are, pulling it off the line here in the U.S. and to be able to hear firsthand exactly how it goes from pellet to a little string of you know, whatever. It's really neat.
Pasta.
Yeah.
Sorry, Sean.
Hey, I call it pasta too, so it's fine.
Yeah, I think it's awesome. Honestly, I wish more. Not that I wish you guys competition, but I do wish more companies would pop up in the U.S. and we would see more people dedicated to the art of making filament. I mean, we've got some good companies here. I mean, you two definitely included. I just feel like, you know, there's just an overwhelming amount of Chinese filament that gets, you know, manufactured in maybe 3 factories and rebranded 15, 20 times. So, yeah.
Well, you all as the consumers get to vote with your money. So
Yep.
buy what you believe in.
Live what you love.
American.
Yeah, I think Jim, Mike, you have a good point. You know, Proto-Pasta has how many lines did you say? 3 lines, right?
Yeah.
And
I mean, we've got more extruders, but yeah, anyway, yeah.
That's what's running.
you guys are both, you know, honestly, I expected IC3D. I expected Sean to say they run like 20 lines or something like that. I never expected it to only be a handful of lines at the most.
Yeah.
I was actually picturing IC3D being even bigger than that. But at the same time, I mean, they're producing 20 kilograms an hour.
Sure.
I can only consume 1 kilogram at a 1.2 nozzle in like, I don't know, what, 8 hours or something like that. So it's like, you know, put that in perspective.
You guys just like batch like 1 color at a time, and you just like put roll. So like, you know, if you were doing, let's say Hi-Fi Blue, Alex, you would run one of your units on Hi-Fi Blue and make how many rolls in one sitting?
Yeah, I mean, we try to do, I mean, it varies kind of on what the pulse of manufacturing is, but you know, we try to do at least a half day's work. If we can do like 1 material in a day, like settle in, then that's certainly like easiest. And sometimes for really high demand materials like carbon fiber, we'll be doing many days in a row.
How many rolls does that roughly equate to?
Hundreds. Yeah.
So basically,
something like the workshop we're going to do tomorrow, we're going to do one-off rolls. You know, I mean, so it's like a whole different animal.
That's a one-off thing, though. I mean, for production, though, you guys are like cranking out hundreds of the same color at a time, and then, you know, you will purge your system and then go to the next color, correct?
Yeah, but it can be as few as 10s instead of hundreds, but yeah.
It just depends, because you guys keep stock in warehouse, right? So it just depends what your stock is and what you're sending out.
Yeah, we don't, as a general rule, we don't make to order unless we get slammed with a big order, which makes it easy to make to order when everything else is in stock. But yeah, we have a stocking plan, and we stock in the same facility that we make filament.
We do the same.
So
it's easier that way.
I want to catch some questions here that are coming through the chat before they go too far. Tony Ryan's got a lot of questions for you guys.
Tony, Big T.
He wanted to know how extruding in the summertime versus wintertime, what's the changes that you need to make for that? I guess like temperatures and humidity.
Yeah.
Humidity.
Well, for us, again, air cooling. Like you're not going to cool, the filament's not going to cool as quickly in the summer. So what you don't want to do is, you know, make winter profiles that push the speed limits and then not make any changes come summer. So you could run conservative all the time, or you can adapt and just make sure that you're monitoring your output enough to shift the process, slow it down basically in the summer. So, and not significantly, but but enough that if you're pushing the limit in the winter, we wouldn't get the quality result we'd want in the summer.
Sean, about the same for you guys?
About the same. We try to put a little heat into our building in the wintertime, into the warehouse. Not a lot because it's super expensive, but we pump a little bit in there. But yeah, so like the settings on the extrusion change a little bit. Not too much of an offshoot. But I guess the biggest thing for us is the drying settings of the material, the raw material and the master batch and all that stuff. Everything has to be dried and moved directly to the machine. Like no air gets to it in the summer. And then in the wintertime, it's, there's like no moisture in the air in the wintertime. Like it's not humid at all. In the summertime, it's just so muggy here in Ohio. It's ridiculous. So in the wintertime, we can get a little more laxed and, well, I don't want to say laxed because that's not really true, but we don't have to worry as much about the moisture and the humidity in the air.
What is so you guys run through a water bath, and I'm sure Proto-Pasta to an extent you guys deal with this. One of the hottest topics in 3D printing consecutively is moisture absorption of filaments. How do you guys deal with that? So like running it through a water bath, obviously you've got to dry it back out, right?
It dries out. The moisture doesn't come from water. It comes from the molecules that are in the air that attach to the actual plastic and material before it hardens. Once that thing hits the water and it zips through, it's zipping through like that. Like it's instantaneous. It goes through a 6-foot bath in a second. Like it's going quick. It's not collecting moisture from the water. It's hardening, it's solidifying, and it's pulling it out, and then it's going through an air wipe. And then the air wipe is blowing all the water off.
Okay, so there isn't like a dehumidification process or a drying.
Yeah, well, there is beforehand, not after extrusion. Pre-extrusion, okay. There's a drying. We have a big dryer. I think I'm not sure exactly how much it holds, but I'm guessing 500 pounds of raw material.
You're drying the raw pellets before you enter the extrusion process.
Yeah. Yep. Okay. Before it goes in the hopper, it's all dry. Everything's dry. Gets put into the hopper, and then it does its course.
All right. Alex, same for you guys?
Yeah, I mean, having dry material is important for the extrusion. Personally, I know there's a lot of talk about drying filament. I'm not totally convinced that a lot of the time that what folks are experiencing is related to moisture. They think, again, printer settings all over the place.
Yep.
I have not been able, I've got filament that's been out for years sitting around the office, and I'm not really good about putting it back in, and I can just put it in the printer and print it. I mean, granted, I'm in the PLA world, but so are a lot of people. And I feel like moisture comes up. I'm like, I don't know if I believe it, or is it that people put other stuff in it, or I think it's a misunderstood topic. It's one of those, like, if somebody sees the vacuum bag isn't like super tight, they're like, oh, like, and even though it's still got the Deskin in it, they're like, oh, this is like this material's moist or something. I'm like, I pretty much don't think so. But
what I've seen with that would be like your nylons. I mean, nylons are still hydroscopic.
Right.
They literally do like sizzle coming out of the hot end when they.
Yeah.
That's different.
Right.
PLA though. That's a different
PLA. I mean, nylon's a different beast. And then the second one that I saw that absorbs on a regular basis is PETG. But again, the rate at which nylon absorbs versus PETG is an order of magnitude different.
Right.
So,
but in what you're seeing in your print, though, I think is highly settings dependent. Like, I can get bubbly looking PLA and PETG, but usually it's because I'm trying to like run too fast or I'm running too hot. If I get the right settings, even though it's been out for years, it seems to work just fine. I mean, I guess maybe if you're like really in the fine details, I've seen folks demonstrating like drying filament and then printing again, and they're like stringing like reduce and stuff, and the print kind of clean up, but not the difference in PLA at least, or in our PLA between like make or break. It prints or it doesn't kind of thing.
I tell you what, I've had a spool of Proto-Pasta sitting out for 2 years, and I printed with it last week, and it was just fine.
I got my high-five glue that I leave laying out. I don't even bother putting it in a bag. I don't have any issues with PLA. Yeah. I don't think I've ever had an issue with the only issue I've ever had with PLA is it becoming brittle, and that's not moisture.
Yeah, which a lot of people, when you look like the 3D printing groups on Facebook, a lot of people say, "Oh, this filament's snapping off. It absorbed a bunch of moisture, or it came this." The brittleness isn't moisture. Moisture makes it flexible.
Yeah,
it's probably lack of moisture.
Yeah,
it's a lack of moisture and or UV exposure. You know, maybe they have a source of UV in where they're storing this, and it's making the filament brittle. I mean, that's a possibility.
I mean, everything man-made has a shelf life, right? Like,
including man,
and woman, and everyone else. But yeah, it's. I mean, if it's brittle, then it's just old. I mean,
I've got a box from 3-4 years ago that just started, breaking randomly. So it's, I'm just looking at that going, I think it's just reached its, plastic life expectancy at this point. It's a relatively cheap Chinese plastic. I don't know what their chemical composition is, but obviously it doesn't like being left out for long periods of time, exposed to all my lights and every other environmental attribute that's in my shop. So, just the way it is.
Yep. Well, and that's one of the things, not to get too far off topic, Joe Mike, you said about like nylon. Nylon obviously is hydroscopic and picks up moisture out of the air pretty readily. If I leave any of my rolls of nylon out for any extended period of time outside of a bag or a dry box, it has to be dried the next time I use it. Yeah. The one flip side of that is nylon, to extend the life of it, you put moisture into it. It stays.
It's a plasticizer.
The problem with nylon is the actual when you bring it up past its glass transition temp and into melting temp, then you're starting to physically boil the moisture in the nylon, which then causes your bubbling. Right. I mean, that's I think with nylon, as far as all the materials go, nylon is the one that's most prevalent in as far as being able to actually listen to it come out of the hot end and sound like little fireworks going off while it's coming out at any speed that you attempt to extrude it. But again, you dry it and it stops. You get the moisture out of it. So it's a matter of the difference between the temperature there. So yeah, you might do material characteristics change given temperature and environment. That's pretty much the nature of material engineering. Yeah, knowing how your material will perform at any given spec. So, I mean, you guys know that. That's like, I am crap at chemistry. So when it comes to like filaments, I just kind of figure you guys throw a little bit of unicorn blood and some eye of newt with some plastic pellets and call it, your recipe. That's your PLA recipe.
Right.
Maybe some of like Chuck Hellebuck's hair in there in apple red. I don't know, but
I used all of Glenn's, so I got the.
I've given my full. I mean, I've got nothing left to give.
I've got to actually hop off. My wife is texting me saying that she needs backup for baby duty. So, guys, it was great talking with you for the short time. So,
good to see you, Joe Mike.
I'll try to get back down if I can, but don't hold your breath.
You take care of that baby.
Joe Mike. Yeah. I'm going to follow up with something Joe Mike said about with the chemistry side of things. In 2 weeks, the next US stream, we have Matt Gordon from Printed Solid, which, Dave, correct me if I'm wrong, Matt has a material science degree or material chemistry degree. What's his background?
Material science and electrical engineering.
Okay. He's going to actually be coming on in the next US stream to talk about different materials and ideal use cases for those different materials. So what, PLA is good for these situations, but this is why you should use ABS instead of PLA or PETG instead of ABS and PLA, the different types of materials. So that is going to be the next stream. What is the date of that? The 16th of November. Just since Joe Mike threw in the chemistry part, and yeah, I don't know anything about the material science and chemistry. I take my best guess at what I think's going to work, and that's it. So
dealing with the chemistry in that, with the raw materials that you're using, are any of those actually designed for 3D printing, or they are for the general plastics industry?
The question was,
well, for your raw pellets
like
that you're getting, are any of those actually starting to be designed for 3D printing, or they're just generic for the plastic industry at this point?
Some are.
yeah, I mean, I think what we use often is an extrusion grade of a material. And there's injection molding grades and blow molding grades. And so it has the right kind of like melt viscosity and such melt strength to stay a noodle shape when coming out of a die end. But I do think there's also some. I mean, I know there's work that goes into like what kind of improved layer connection between making material modifications. It's something that they consider in, for example, like the food products, right? You've got a sheet that you're heat sealing to another plastic, and there, that inner layer or that inner layer connection there, like maybe that's useful for 3D printing or something like that. So
okay.
Sometimes they'll be like, you can use this for 3D printing, or don't use this. And then I'll be like, don't use it. I'm going to use it. And it's fine. Like, it doesn't matter. It's plastic. It's plastic, guys. Plastic is plastic. It's plastic. We're all making plastic rods. Some is prettier than others, but that's fine.
I think it was mentioned in the European stream last week that BASF, I think, is that it? The major plastic manufacturer is getting into filament production. I'm wondering what sort of impact that's going to have, since they're the ones making the pellets. Now they're taking the process right through to making the finished product.
I mean, that's kind of a trend with big name manufacturers, and even though they put their brand on it, they may or may not be making it. They may be farming it out.
Right.
It's really just like it's a validation that the market is getting big enough that they think it's worth some attention. So
yeah, and those bigger companies that are already in the plastics game, I mean, they're already making plastics. We're technically taking, no one's taking business from anybody, but if someone were to take business from somebody, we would be pulling their customers towards us, because they're not doing 3D printing stuff. They're doing stuff for film, like, film that you make film and whatever other kind of plastics that you make, extruding. And honestly, the more people that make filament, the better. Like, let's all learn and share together. I mean, let's make this as awesome as possible for everybody. So, I mean, that's my thought on that. Like, if you want to make it, good on you. Cool.
What is so coming down the road? I mean, Proto-Pasta does a lot of PLA, some polycarbonate. You guys do have an ABS
Oleum polycarbonate ABS alloy. Yeah, a blend of the two.
Okay.
Do you have carbon fiber CFABS?
We do not.
You don't? Okay.
Sean wants you
Get
to.
on that.
Is there any materials that you guys are looking at coming down the road to be adapted to 3D printing? So we're seeing things like Delrin and things like that with MakerBox. I get exposed to a lot of stuff. I like Delrin. I always knew Delrin as something that had to be machined.
Right.
Never thought that it was going to be able to be printed. And now, with that said, Delrin's a pain to print with. Although E3D's new hot ends and stuff may change that. Is there any materials that you guys can foresee possibly, without giving away any secrets or anything, obviously, but is there anything that you're looking at thinking we'd like to maybe try to make up a recipe for this?
Well, first off, we aren't chemical people. I mean, we take good chemistry and we try not to mess it up, and add our spin on it. So like a real unique like chemical composition would be the result of somebody coming to us and saying, hey, we think, what you do is the bee's knees and we'd like to see this come out through your brand. I think the reality is the chemical companies and such are, mostly trying to get this out within their name, when they do something new like that. Where my focus is and my interest is, okay, being a group of engineers that started Proto-Pasta, our interest is in function. I mean, we added PCABS to the family of materials originally, but it's like it never really took off because it's such a pain to process. And it's gotten better with the hardware that's available now, since there's better hardware than there was 5 years ago. So that's improved, but my interest is still in stuff that folks can really use. I've played around with nylon, for example, and I'm just not a big fan of the user experience, even though I'm a big fan of the actual material once it's apart. And that's what I used for the first 10 years. I was in laser sintering with, on the industrial side of 3D printing, $1 million machines, nylon powder, and that stuff's tough as nails and like makes really durable parts. And of course, the laser sintering process where you don't have supports is pretty cool, for freedom of creation. But we've tried a lot of different polymers, and we want to pick things that people can use and enjoy. And it's not, for us, it's not about like the next exotic material that nobody can really process. I don't want to sell something where 90% of the people like can't figure it out, and like I know there's people that like that journey, and to be honest, we would too. I think, but we want to produce things that people can have success with, and make beautiful parts and make usable, durable parts with. So yeah, we're looking at some more. I mean, it's PLA is strong, it's stiff, but there's a lot more like impact durable options out there, and we're certainly surveying the space. And we've processed a number of more impact durable materials, and we'd like to make more beautiful impact durable materials and make more also just like easy to use functional materials. Sorry. I need another drink of my tea is actually out. I'm going to walk away for a second to get another cup of hot tea. All right. And I will be right back.
Proto-Pasta covers the category. A lot of people, when you watch the MakerBox community, people who are into printing PLA, PETG, and ABS, and none of the, so to speak, more exotics like nylons and polycarbonates, poly smooth, stuff like that. Everybody, not everybody, but there's a large group of people with the subscription boxes that say, when we get a functional month where all 4 filaments are technical filaments, sometimes hard to print filaments, everybody complains in the Facebook group. that they can't print anything in this box because they're not set up for it and stuff like that. Proto-Pasta makes the pretty stuff that everybody can print with, which is nice. But it is definitely a go-to. And I've only had experience with IC3D's PETG, their accidental pink. The stuff is
That's awesome.
That pink was totally accidental.
By the way, you know, Maker Box, we got a plan in place. We're gonna work on fixing that little problem for you guys.
Oh, that's right. Yeah, there was a little bit of a survey that went around on Facebook.
So we're working on that.
What was the problem?
People, you've got two categories of people with MakerBox, and then some who sit in between them. You've got the people who want stuff that they can print with on any printer without, I don't like using the word newbies, but beginners with 3D printers who aren't doing functional parts. I mean, people aren't printing parts for their lathe like I did when I first got a printer. They want the pretty stuff to print with and easy to print. But then there's the other group of us who are more interested in the exotics, the more exotics for 3D printing, like polycarbonates, glass-filled stuff, things like that.
Functional material.
Functional, yeah. And
you can have both, though. You can have success and ease while having function.
Yeah, and
what's wrong with that?
You just need two printers.
They've been doing a really good job of balancing the two, where we tend to get
printers
and too pretty filaments. But yeah, you've got those two sides, and then you've got the rest of us who are in the middle who, you know, I like getting a pack of just plain PLA out of MakerBox, but then at the same time, I don't have one here. Oh yeah, there's carbon fiber PETG. In the same, those came in the same box. I like that. I like the mixture of them. But you got people who want more technical and people who want more pretty. So MakerBox is looking at ways to fix that. And I know they had mentioned maybe 2 different subscriptions.
Oh, geez, that's a lot of work. Sorry, dude. You got hosed.
Boss, I don't have to do the physical labor. I just have to sign the checks.
Really bigger checks.
One of the questions came up in chat is, do any of you see the day where we're moving away from filament and having, it wouldn't be, you know, pellets as you see them now, but some sort of material like a pellet going into a printer, so you have, you know, full color 3D printing minus the filament?
So before Alex and Sean answer this one,
okay,
based on tonight's conversations, because I've looked at things like Joe Mike, looked at the Filastruder and other home filament systems. Based on what you two have told me tonight, I don't ever want to see the day I've got a pellet printer sitting on my desk. Go ahead. With that said, you guys can go ahead and answer that.
Yeah, I don't want to see a pellet printer myself, but something like printer toner and my color laser printer, something like that.
Right.
So, oh geez, Strata Systems came out with a printer that actually injects ink into the filament as it's coming out. And I believe it just came out. I just saw the PDF for it, and it's pretty wicked. I'm not gonna lie. So that's a threat, but a minor threat because they kind of just keep to themselves and do their own thing and say screw everybody else. But because they have like their own proprietary stuff, so I don't think that's like gonna affect our market. I think that's because they're kind of in a league of their own. But that's pretty cool. If, you know, more people can nail it like that, you know, then we'd be onto something. But as far as commercial use goes, I don't see that happening anytime soon. That looks that good.
Yeah, I mean, the filament process is really, for printing, is really quite reliable, actually, with good input.
Yeah.
And I mean, I think we already see some pellet uptake, but you just don't have the same control. And it makes sense when you get to more volume consumption. But still, like I don't know. I mean, I've seen a few Kickstarters around pellet-based things, and they just maybe it's because they're in the wrong marketplace, trying to appeal to consumers who don't really care or know the difference.
Right.
I mean, it's an industrial application thing for big stuff. It seems
That's like super industrial. That's like
Yeah.
you got to be printing something big to be using that.
I mean, I'm not going to lie. We've talked about more than once taking our extruders and making a giant gantry to put them on and spit a lot of plastic out. That'd be a hell of a lot of fun.
Hell yeah.
But it's kind of hard to justify without like a intended application or customer, or, you know.
Right. You've seen CNC's printer. They actually go out with the printer, the Big Daddy.
Yeah.
But I mean, I don't think we're ever going to really see, you know, raw pellets for consumers. I mean, I think that's asking too much from the consumer to think about the mix, the toner, all that kind of stuff. Some way the home person is still going to have some sort of processed material. I mean, we might move away from filament and move towards, you know, a cartridge with an ink block on it, you know, a big plastic block or some other random invention. But one way or the other, I think plastic does have to be processed for the home person. I don't
even still, even still, if there's a new invention, like with our conventional IP, like it'll be protected and you won't see it like in mass for 20 years, you know. I mean, so I think it's pretty rare that something new is going to come along and then sweep away you know, what exists at the moment in a short time period.
No, I mean, it'll be, if anything, it'll be just some new concept. Somebody tries to get in consumers and we see a slow growth, and it'll take a long time just to happen. But I don't think we're ever going to see raw pellets in the house. I just don't. I don't see that as consumer.
Not raw pellets.
Yeah,
it's going to be a processed good.
Yeah, it would almost, you know, home user pellets are probably too cumbersome because of the size of the augers. Proto-Pasta's augers are 3/4 of an inch, or the screw, sorry, are 3/4 of an inch in diameter. That's going to be one big beefy machine to attempt to feed pellets through it. So the next step to make that smaller would have to be powder. Taking those pellets, grinding them up into a powder. Right. But then you're at the point of SLS machines and doing laser sintering, which, I mean, there's already talk and people trying to develop desktop laser sintering machines. So,
and the home people are
already has its place, so to speak.
The home people are going to respond well to SLS because, I mean, we saw what happened with glitter at Murph.
Yeah, exactly. Yeah, so, you know, picture that now with something moving in a hopper that you're trying to top off it because you're getting low instead of swapping the spool out. Now you're trying to dump powder in. Heck, I try to dump sand in a print on my CR10 as the bed's moving and as the printer's printing. And I've got sand laying in the bottom of my enclosure still because of it.
Yeah.
The thing is, okay, what's the story behind the sand?
Oh, I printed baby Groot's head, which actually now has been retermed Teenage Groot. I printed it. It's actually bigger than my head for in my garden, and it's completely hollow, no infill at all. And as it was printing, I was filling it with sand to weigh it down so it doesn't get blown away in the wind, because it's only what 2.2 pounds, was just over or just about a spool of filament. So the sand's just added weight so it doesn't move.
Awesome.
So, you know, one thing that we haven't talked about that I kind of wanted to touch on, because I thought, you know, Proto-Pasta, IC3D, you know me, we've all sat down and talked at one point or another. You've talked with, you know, us guys. But I wanted to bring up the spool itself. I thought that would be a good little topic because it's amazing the people I've talked to and how much emphasis people put on the darn spools.
Okay.
and I wanted to hear about you guys and your opinions on it because Proto-Pasta has a unique take on it, and IC3D, you've got a good solid spool.
Yeah, it's beefy.
But you've also I've seen you guys change a couple times too. So I mean,
yeah,
talk about that. I think you both got a good story on that.
Yeah, well, actually, I was digging through some old boxes today, tidying up, since we're gonna have visitors tomorrow, and found an old plastic spool because we started using plastic spools with our original Kickstarter. We had 1K spools, and then we did like 750 spools, and eventually, like we were talking to, it's such a conversation point, or was even years ago. What do we do with our spools after we consume the filament, that we made it, we saw it as something we could, make an impact in or make a difference. So we designed our own cardboard spool, and in fact are on a second generation of that now, which has been a couple of years. But for us, it's a beautiful thing. We send our filament all around the world. Doing something like a core charge and take back doesn't make sense when you're sending material to Europe or Asia or what. So we considered something like that, like a deposit and a core, and it wasn't gonna accomplish what we wanted to. So the cardboard spools, like recyclable, disposable, wherever it ends up in the world, are 500-gram spools. Have only 80 grams of cardboard material. Our 1 kilograms have just 90 grams of cardboard material. It's corrugated. It's lightweight, but still rigid. It's plenty durable. We don't have like a bunch of issues where people are rejecting our product or whatever because the spool fails. They're more sensitive. If you drop them, sure, they're going to dent, but it's meant to be disposable. So like really, for the most part, who cares? A little less tolerant to the like roll around on the outside kind of spool holders. But you know what? We're all makers and crafty. Like you can put a ring around the outside that you printed in plastic.
Yep.
And solve that problem if you're really committed to that kind of unspooling. If you want to just mount to the core, well, it's just like the plastic experience. We go through a lot.
On yours, two interesting things to bring up on yours that I'm curious about. I've dealt with a lot of spools, as you can imagine, and I've gotten through a lot of that use chipboard and metal cores and stuff like that. And when they pull on it, it naturally pulls the filament into the inner, against the sidewall and the filament, and it jams up. But yours guys don't do that. So you guys probably went through a bunch of cardboard to get the stiffness right, so it actually acted like a plastic spool. I was going to ask you about that. But the other thing I was going to ask you about is to confirm the rumor. Are you guys actually gluing them together by hand in your factory?
Yeah, absolutely. That's a rumor. I thought we were pretty open about that. We have the sides printed locally, and then punched out, and the cores cut locally, and then we assemble them by gluing the sides on the cores. Every single one of them has a human touch, for better or worse.
Sorry.
Yeah, and it's not. People will be like, "Oh, you're just being cheap or something." I'll be honest, the raw material cost is less than a plastic spool. However, the additional work necessary does not make it by any means easier. And the biggest challenge we probably have to overcome is that they do come from the manufacturer with a ton of cardboard dust on them. We painstakingly vacuum everything meticulously so that no cardboard gets on your plastic. Because we know that is the first thing that folks like brought up as potential, like a reason not to use it. So we're not going to give you the reason. You have no excuse.
So are they die cut?
They are die cut, yeah. And we did go through, like, I don't know, we considered many different corrugations, and we chose a supplier based on having this very specific corrugation that gave us the kind of performance that we wanted. Go figure, we're pretty particular.
Yeah,
Have to be.
the only complaint I ever had with the Proto-Pasta spools, and maybe this is possible, maybe it's like just super complicated to do it, is having, you know how the plastic spools typically have a hole or two holes to zigzag your filament through to hold it when you're not using it. I always end up taking my Proto-Pasta spool, put a notch in it with my pocket knife, and that's where the filament goes to hold it. But that's like the only thing that I've ever looked at the Proto-Pasta spools and said, you know, this is the only thing I don't like about them. They are lighter. They actually I'm using the 500-gram spools. They are 750, whichever it is. They do fit nicer in the bin that I store all my filaments in. I can fit more of them in a row than I can the plastic spools, whether it's a 750-gram spool or a 1 kilogram. But yeah, that's the only complaint I ever had with it was I got to put a notch in it to hold my filament. Like,
but are you in the 175 or 285 camp?
175.
You just slide it in the corrugation, no modification required.
Yeah, as I was talking saying it, I thought about it. I was about to go over and get a spool to look at to see if I could do that because I never actually thought about doing that until
it's pretty slick. It actually wasn't intended. Total dumb luck. So, but it works out. One of our customers pointed it out to us, and we're like, "Oh yeah, awesome." So, but the 285 doesn't fit without harming the spool.
Well, in 285, I think you have less of a problem of tangles when you let it sit against itself.
Yeah, totally. Like it just, I don't have to, I feel like I don't have to worry about manage the end the same way that you do when you're working with 175. Yeah. It's just like, yeah. So, and then the other thing is if you are in the if you're not supporting the core and you are just like rolling around on something that sits on, they are lighter weight, so like it'll fall off of that spool holder if you're not careful or what when it gets down to the bottom. Now the other reason we got into doing our own spools is because of the core diameter, and since we do mostly or we started and do a fair amount of stiff composites to give a good user experience, we wanted to have a larger than standard spool core diameter.
Yeah, that's always nice to have when you have composites, especially if it's brittle, like CFABS or any type of carbon fiber. Because I was respooling some for the print shop, and it just totally snapped on me because the inner diameter was so small. It was trying to get that curve to wrap around it, and it just went snap, and it hit me in the face. I was like, "Dang it! All right, I'll need a bigger spool." So,
yeah. So,
question for you guys.
Yeah.
All right. So, and it's always been my strong opinion, but I figured it'd be interesting for people to hear about it. The vacuum bagging of the filament. Because I have really strong opinions about it, and I'll tell you guys and then have you guys comment on it and your concepts behind it. So I have a spool here of, we'll say, an unnamed brand, but we know what it is. Starts with the A and ends with Zon. They seal the sucker super tight, zero air inside of it. And then they put the desiccant right in the middle of the plastic core.
Okay.
That is my biggest pet peeve in the whole world. If you're gonna put the desiccant in the middle of a plastic core, you gotta have a little bit of air in the bag, for one. Or the only thing you're keeping dry is the actual center of the core, and that's useless to anybody. The other,
you can say you have a very dry core.
Right, exactly.
I thought you purchased a holder for your desiccant.
Well, I've seen some manufacturers, they actually just put the desiccant on the outside of the roll, and I'm like, okay, that's a decent solution. Placed on top of the filament. I'm like, it's better than nothing. But the other thing is having a little bit of air in there, because if there's no air in there, the desiccant's not going to do too much. But what's worse is that when the plastic is sealed all the way tight to the filament, moisture can permeate over time. So you get less of a shelf life out of it. That's always been my opinions, and that's how I kind of judge people, is based on how tight they vacuum seal everything.
So you're saying if it's sucked to the filament, it's too much. It's going to build up moisture and it's going to degrade.
Almost 100% vacuum, it's too much.
Okay.
So, you kind of want to have about like an 80. You just want to have just enough air in there that you can move the plastic around. And it's like a color fab. They do put their desiccant in the middle, but there's just a little bit of air in there. There's just a little bit of air in the bag.
But is that consistent throughout? Like if you take per brand, is it consistent per row? If you take one pallet of, say, Amazon, or one pallet of color fab, and you look through every roll, is it going to be consistent?
On color fab, yes. That's one of the reasons why we sell it, is because they are consistent on that part. The Amazon, I've been pretty consistent on from everything that I've seen. We, of course, don't sell that.
Right.
But I see some variation, but as long as it's less than, a full vacuum, I always find that it tends to be a good spool. As long as it's less than a full vacuum, it's okay.
And I wasn't saying that to say like, hey man, you're wrong. But I was like, some companies aren't consistent with that stuff, and somebody will get it and be like, well, I'm not going to buy this anymore because I think this and whatever, and they only purchased one spool of whatever.
Never judge a company by one spool has always been my rule.
Right.
But I will judge them when their color is off, when they say I'm buying the same orange twice.
But I don't have much opinion on vacuum sealing, but we do make sure that our desiccants are on the outside where the filament is, and I don't know, our amount of draw on the bags is not probably the most consistent in the industry, but I'm not in the impression that it matters that much for our stuff, other than impression.
But that's always been my thoughts, and as you can imagine, I spend every day with this stuff, so I've become really strongly opinionated about every aspect of a package.
So can I give my perspective as an HVAC technician, where I run vacuum pumps day in, day out, because moisture is critical? I honestly, when it comes to spools of filament, almost could care less if it's vacuum sealed or not, because with the line of work I do, moisture creates acid if there's moisture in a system. So I run a vacuum pump, and like you watch these guys on YouTube and things like that, King of Random, they do a lot of stuff with pulling a vacuum. They pull a vacuum to 30 inches of mercury. If you look at the gauge that they use, they do it over 15 minutes or something like that. 30 inches of vacuum is nothing as far as evacuating for moisture. It's not doing anything. It's pulling air out. It's pulling it into a negative. But you don't lose moisture in the air. Moisture doesn't boil off until you start to get down to 1,200 microns.
Right.
The vacuum bags aren't going to hold that kind of a vacuum. So I always kind of laugh.
But too much vacuum is going to make too much moisture permeate through the plastic eventually. Correct.
Yeah, with the types of plastic that it is used to wrap the filament, it really is not that critical. Like Alex said, the driving force behind moisture being a problem in filament, I think is so overblown considering what I know from my trade. In all honesty, they could take and fill the bag with a slight bit of dry nitrogen, which is probably cheaper than actually pulling a vacuum. And it would be actually better. Less permeation, because you do have a little bit of fluff to it, a little bit of pressure in the bag. Minimal pressure, but it's pushing out rather than the atmosphere pushing in on it.
Built-in packing material.
Yeah.
So now here's another thing to topple on top of this cake of awesome. What do you think about foil packing as opposed to plastic packing? Like
You're talking like Mylar bags?
Yeah, like foil as opposed to plastic.
Better for you.
I was gonna say we started with Mylar, but we found it was much more easily damaged. And so then you just end up with a broke open package. And is that really better?
Nope.
Yeah. Filament.
And you can't see the product, which sucks.
Yeah.
Right. Right, exactly.
Ships all, at least everything I've ever gotten of Filamentum, they put theirs in a Mylar bag. And that's exactly my problem with it. I'm like, okay, well, cool. They put it in a Mylar bag. That is better for UV blocking on it. So I put my Filamentum back in the UV bag. Except I got to open every damn UV bag or Mylar bag to see which filament it was that I was looking for. So yeah, I agree. Mylar is easy to break.
Yep.
It is good for UV blocking, though. I'll give it that much. So if I have something that's a more expensive filament, I do keep those Mylar bags to throw it in because, again, all my filaments in a plastic tub. Most of it is unwrapped. The only stuff that I keep in a dry box is my nylon. And it's, you can't see my basement lights off, but it's hanging back here on the wall. I kind of stole Rep Box's design and turned my dry box sideways. Now I can put like 6 spools in it, but I just keep my nylon in there and that's it. And it's literally hanging above the only printer I have that I print nylon on.
Is that why it's not printing right now?
Actually, all my printers right now. I have one project that I'm trying to finish in a week because I'd like to bring it down to printed solid with me. And that's my focus. I don't have no plans on running any printers this weekend for anything. There was, you guys want to talk, Dave, if you have questions, Richard, if you have questions, go ahead and ask them. I'm going to scroll up through the chat here and see if we got all the questions.
I first want to say hi, Shane from Prusa Research. Is Prusament on Amazon right now? I think I'm going to place my order.
They promised by the end of the year.
I heard they promised by tomorrow. That's what I heard.
Well, they promised 6 months ago they all have powder-coated PEI sheets too.
That's why you don't make promises. Did that get him upset?
Not yet.
There's a question now.
I'm hoping he does.
Yeah, he's got a question up there for you.
For the filament trinity, without breaking any company's project secrets, NDA, what would be the one dream filament you would make? That's a good question.
The one that doesn't break.
The one that doesn't break.
Prints at any temperature.
Right.
Actually, that is a good question. Alex, you've got the ability that if you have a filament, you can make it. And if it works, you can market it. Is there anything that you really would like to try that you haven't yet? And as a flip side to that question, what's the craziest thing? I know, like with Joel, you put the bacon in it. You put caffeine in his batch of High Five Blue, the original batch. What's the craziest thing you guys have tried? Is there something you'd like to try and something that you've tried? Let's put it that way.
Yeah. To be honest, I've gotten a little bit out of that like way of thinking. I've had to think more about how to like move forward an organization and less about like just thought experiments playing around. But it's cool to like, I've had some ingredients that make buttered popcorn filament on the shelf for way too long now. Ordered cornmeal and I had no idea this existed, but I found it is dried powderized butter. So it was something that came up enough times on Twitter that I was like, okay, I'm just going to see if I can buy the ingredients. And at some point I'll make this. Could turn out horrible, could be awesome because you all know that like with microwave popcorn, it can be the best smell in the world or the worst, depending upon how it's cooked. So I don't know whether it's going to be a good filament making experience or terrible.
You could market it as temperature indicating filament. That if you're
right,
temperature, it smells like buttered popcorn. If you're printing too hot, it smells like burnt popcorn.
right. There you go. Know your process window.
I don't want to be in your warehouse when you do it.
I mean, we've done pine from our family Christmas tree for years, and that's really labor intensive to strip the tree of all the needles, dry them out, use the Vitamix to turn it all into powder.
Is that actually how that works?
Yeah, sift it so that all the particles are small enough to not clog your nozzle, and then finally mix it in with the plastic. So that's the process for the pine filament that we make.
If you hadn't said that, I would have continued to think that it was just some kind of like scent additive to it, not actually ground up pine needles.
And my family's Christmas tree, so it's kind of. I save it from the year before, and then let it dry all year, and then yeah.
That's pretty cool.
It's been a thing. We've done that 3 years in a row. I don't know.
You guys doing it again this year?
I don't know. Every year I say I'm not going to do it again because it's so painstaking.
Like, do you have to deal with sap and stuff that's in the needles, or is that not a problem running that through the extruders?
It's not a problem. I mean, we stopped making coffee filament partially because it was like extra gooey and sticky and jammed up the extruders more than we liked, and it just was like becoming more disruptive than it would have liked. We've pulverized a lot of things and dried them.
Coffee filament.
Yeah.
I had a great secret. What I would do is I go do these educational shows.
Yeah.
And I would load the coffee filament in the morning and the bacon filament at night. And every single teacher just came to the booth wondering where the smell came from. And I'm like, have I got a sales pitch for you? It worked every time. I'm just that coffee.
Yeah, it's fun. It was a fun concept. The aromatic concept is really fun. I've kind of been out of that and into the colors. I feel like they're more broadly like enjoyed, a little less gimmicky. But it's really cool. Like, I don't know, it's really cool what you could do if you're just like open to messing around with it. So back to the question, actually, I would love something I've tried a couple times is to create a more biodegradable filament. The problem is that they always also seem to be more moisture wicking, which gives a worse printing experience. So, and I mean, that's part of what makes things biodegrade, that they like take up moisture and everything. So I suppose if and when someday that like dry filament storage becomes a standard, like delivering with printers, and you don't have to like, and it's not complicated, that maybe I'd like to pursue, a more compostable filament that's also beautiful, because like so much of what we make is really in the end going to be disposable, and it'd just be wonderful to make it beautiful while it's meant to be, and still, disposed of in a better way in, end of life. So, because PLA is not like biodegradable in the near term future. So anyway.
So we were talking about the scented filaments and stuff that you guys have made. Did you guys ever look into making a filament that, so like the coffee, it smells like coffee when you're printing with it, but then once you're done, it smells like plastic.
Right.
Part. Like, did you guys ever look into a way to make something that retains its scent after it's printed? I actually keep wanting to experiment with the matte fibers because it's got the fiber in it.
Yeah.
Just putting like
essential oil
or something into it, soaking it to make an air freshener type deal out of it, just to see if it would work. I thought that would be something neat for the Etsy shop.
Yeah. I mean, that should work. I was pretty into that for a while, exploring that. And actually, like with a more compostable filament that is a real pain in the neck to print, really moisture uptaking, was the first and only time I came up with something that, excuse me, that actually still smells when it's cooled and at room temperature. We actually just pulled that out today too. I have a bonsai planter by Gordon from G-Create, that file, which I did in this like compostable filament that I cooked up that has lavender in it, which gives us this beautiful texture to this already sort of like woody color thing. And you can still, I can still smell the lavender, which happens to smell more like snickerdoodles, but it's kind of neat that works. And the matte fiber we've played with will take up. Sorry, I'm so squeaky. We'll take up the like oils. We can wick in oils on our side and do the whole scent thing with the matte fiber if we wanted. We just haven't pursued it. Just putting the oils in without some solid to hold the oils, doesn't work very well. It just vaporizes in the process. But having us starting with a solid that has oil in it, like sort of protects the oil through the process and allows it to come out the other side with still having scent.
Yeah, and obviously to an extent it's still limited on the amount of time. Just like, you buy an air freshener for your car or whatever, it only lasts for so long. But
sure,
yeah,
right.
I know that was something that, a lot of people, you saw them say about like the coffee and stuff. Like, yeah, it smells like coffee when I'm printing, but that's it.
Right. Right.
I was just curious how much research you guys have done in extended scent.
We also tried some chemical scents because that is a thing for industry to be able to scent plastic. And boy, those were just like hurt your nose potent, like were not enjoyable at all. Like just smell like detergent or like, kind of ruin the experience, ruin our vacuum too.
Do a novelty filament, just the worst smelling filament possible.
Right. Like the whole Harry Potter jelly bean thing.
Yeah.
Oh gosh, those are horrible.
And people would buy it and want to print with it just to say that it smells horrible.
You know what? You should come out and make some filament, and that's what we can do together.
There you
go. Perfect. We'll just sample my body odor. That'll work just fine.
Just ring out a pit. You'll be good.
I'm not buying that, Dave. Sorry. There was a question. I'll let Alex answer this one because this is the one question that gets asked over and over and over again anytime anybody recommends Proto-Pasta. So I'll let Alex kind of answer and defend this one a little bit. And then since it is the 2-hour mark, we'll go through outros. And if you guys want to continue after we do the outros, we'll keep going as long as you guys want to go. So that question was, and I'm going to twist this a little bit. In the chat, Lightspeed asked, why is Proto-Pasta so much more expensive than any other filament? Which
is not entirely true.
It's not entirely true, yeah.
Right,
but go ahead and defend what makes Proto-Pasta worth its money. I know why I recommend it to people, but let's hear it straight from you, Alex. Why do you feel that that's where it should be?
Sure. Yeah, well, I mean, I want to start by saying like everybody values different things. So like if you don't value what we do, then I get that it doesn't make sense for you. But enough people value what we do, which I'm grateful for because I want to do different, new, interesting things. I want to make the best and most interesting filament that we can. And it's not about like mass producing for us. We don't have like mass production efficiencies so much. And it's really just about like paying to keep exploring. I mean, folks keep buying filament. We get to keep exploring and making new things. And yeah, so I like to think that we offer a good value for folks that share our values of like what's interesting for them.
Here's the thing. Here's the thing about Proto-Pasta. It's special. You're buying something that's special. It's not like anything else that's on the market. People can throw glitter in and do whatever, but they are putting their heart and soul and love into this product and spending money and, you know, having other people that have the same goals to make this in the US. And it's an expensive process, guys. It's an expensive process, and these guys are doing that, and they're pushing boundaries. It's special. So you're going to pay for, what did Lightspeed say, $60 for a kilo of PLA? Yeah, you're going to. And that's because you're buying for what it is. It's special. And that's all I have to say about that.
It's an artisanal high-end filament.
Yeah.
Yeah.
Yeah, I don't
even. It's like buying Starbucks or buying, you know, your favorite espresso, or, you know, I want to buy, you know, Death Wish coffee. Yeah, you're going to pay $30 more. Good luck. Like, you're buying Proto-Pasta. It's special. It's made with love.
Yeah, I don't use my Proto-Pasta for prototyping. I use my Proto-Pasta because I have something that I want to look good. The other argument I have is, in all honesty, Proto-Pasta is one of the best printing filaments that I've ever ran through my printers. You almost can't screw up the settings. I know we were talking about printing too hot and printing too cold. It doesn't matter how I print Proto-Pasta, I get a good print, period. And that's not, I'm not saying that because Alex is on here. I've been saying that. When somebody asks about a filament for certain artisanal prints, Proto-Pasta a lot of time is what I recommend to them. Plus, it's not just PLA in most cases. It's not just PLA. It is the HT-PLA. So, like Alex said at the very beginning, not only do you have a more practical, functional part that I think you said glass transition is 170. Was that right?
Well, the glass transition doesn't change, but yeah, it'll retain stiffness to like 160.
After you do
not full stiffness, obviously it goes down with temperature, but yeah, after heat treating.
Versus PETG is 70 degrees Celsius, I think.
70 to 80, something like that. Yeah.
Is that about right, Sean?
What was the question? I'm sorry.
PETG's where its stiffness starts to drop off at temperature. It's like 70 to 80 degrees is where it starts to drop off.
Yeah, somewhere around there. Yeah.
So, you know, it is HT-PLA. It's not just a regular PLA as far as I'm concerned.
And HT-PLA raw material is way more expensive than your standard PLA.
Yeah.
We're not skimping on ingredients. We're not, I mean, we really don't skimp on anything. And we're just putting our everything into making something special. I think, thanks, Sean. You said that very nicely. Yeah, actually, it's flattering to sit on here and have you folks understand like what we're trying to do. And it is different and it is premium, but it's nice that enough folks understand and appreciate that.
Yeah. I have at least a part of every Proto-Pasta spool that I've ever bought in the last 3 years that I've been 3D printing. Every spool I bought, with the exception of glitter. The glitter fill, I've used the crap out of that because my daughter loves me printing stuff in it. So I've printed a lot of stuff for her and a lot of stuff for our Etsy shop around Christmas time. So I have burnt through a roll of the blue glitter, the Winter Flake and Glitter Flake. But otherwise, like those, they have specific uses.
Yeah.
They are the pretty filaments. They're the ones I want a pretty part.
When you want to make a keepsake, not just something that's either just purely for function or for prototype throwaway, then it's
if I'm gonna paint it, it is the cheapest stuff I can find.
Right.
I don't care what it looked like underneath.
It's also how you value your time too. Like, yeah, if you're gonna do finishing, or like, if you if you are someone who doesn't mind going through failed prints with trying to get the cheapest filament you can, well, you know, that's what works for you. That's cool. When I'm printing, I really don't, I want to just make something beautiful, and I don't want to like go through failure after failure. And I seek to bring the same thing to our customers, to bring them something beautiful that they can have success with.
Right.
Lightspeed asked me to clarify his question a little bit. He said, first of all, he loves Proto-Pasta.
That's not what I heard.
Yeah, I think we kind of all jumped on the supporting Proto-Pasta, but honestly, I really do. Yeah, let me read through this. He was asking, with companies like Prusa that are stepping up the standards while driving the pricing down, he wondered if there's any concerns from Proto-Pasta as far as, I guess, a competition, or if it's going to steal business away from you, is more so what he was getting at with the price.
Oh, right on. Yeah, well, I mean, I think the marketplace continues to have competition, and I think that it challenges each of us to find out and to be sharp on like what's our role, what are we good at, what's our value proposition. So for me, I definitely think the message, I think Prusa has raised the bar in some ways with Prusament, at least the communication, the way he's conveying it. I mean, it's a nicely packaged product. He's doing a lot of things right, but I think our strength is in, again, like doing a wider variety of products, and so, you know, getting closer to custom for individuals is a different direction. So competition in price or competition in offering more value, or, you know, like standing out. Sure, it every little bit changes the marketplace, and I think it challenges us as companies, as makers, to like be sharp on what we do, and think and like rethink, like, are we focusing our efforts in the right place? Are we leveraging our strengths? Are we telling the right story? Or, you know, one thing that Prusa does well is not afraid of being like bold on like some of the calling folks out in the way that he did with his, our filament's better. And our slogan's world's best filament, like historically, which is actually kind of a joke from the coffee filament. If you guys have ever seen like Elf, and like they're like, it came from that, like, because the coffee, world's best filament, and we kind of just hung on to it because we're kind of like, it wasn't intended to be a totally serious thing, but we do try our best to make, but we don't think that other people don't make good stuff too. It's not meant in that way, but I digress. I forgot where I was quite going, but anyway, yeah, certainly. I mean, it's, especially consumers, like, we all have only so much money to spend. And if somebody else is offering something good at a good price, then like it's going to attract folks dollars.
And sorry, I didn't mean to cut you off, Alex.
No, please.
Okay. Save your voice a little bit.
Thanks.
The thing I've noticed is, first of all, Prusa has this, and they can afford the machines that can produce that kind of stuff. We have to manually do it and get that kind of a tolerance. And we get, I mean, personally, us at IC3D, we market it at, 0.05 or whatever, or 0.5, plus or minus. But really, we're getting like a 0.15. So we're getting like the same as Prusa. Prusa is enticing you with a wrap, with a beautiful, beautiful wrap that is just beautiful. I mean, I think it's gorgeous, and that's what people are going to be like, oh, wow. Oh, it's so nice and perfect. It's beautiful. well, that's better than this one over here, but is it better than that one over there? Who knows? You haven't tried that one over there. You're just enticed by the marketing and by the wrap and by the brand.
Yeah,
So,
and he's doing good with a lot of those things. I'll have to say,
yeah, for sure.
like having received the red, I've seen a roll of the red, and I was not impressed by the color, but everything else, I mean, because it was just red. I mean, but that's also, you know, I like to make things that have texture and what. So,
Alex,
I like your texture, Alex. I like the texture.
Anyway.
One more quick question, and then we'll do outros, because I did say I'd ask this, and I forgot actually. Has either one of you considered making, or have you heard of other manufacturers considering making filament instead of just an open spool, making a spool box like Cat5 cable comes in, and your different control cables and stuff, being able to spool out from the box? That was from IC3D Design.
Cat5 cables you can bend them and they'll stay in the same shape. Filament, you bend them and they'll either bend or they'll snap. I mean,
I think he's referring to the spool in a box, not so much where the cables just like ran into a box and it can only come out one way because it went in one way.
Right.
I think the boxes that actually have a spool, you don't have a filament box. Take and sit the box on your desk, and the filament comes out. It's like a dispenser.
Pull it out from the
He just doesn't want to print a spool roller.
Yeah.
Well, he can buy one. No. 2-day shipping, baby. No. No, I haven't given it thought. Honestly, I'll be completely honest. I haven't given it any thought. I don't think
it's a whole different kind of winding like setup. I've seen 3D Fuel market fuel in a box, which is supposed to be that, but I don't know if it actually exists physically or if it's just an idea from them. Like I'm not sure whether it's actually a live product or like.
You know what I think it might be, because now that you say that, I never actually understood it. But if you go to Micro Center, they sell 3D Fuel, and it's a box with a spool inside of it, and the corners kind of cut off of it. And I never realized that maybe that's actually the. Oh, is that different? Okay.
Yeah. No, they have like I could look it up, but I don't know. They have like larger capacity boxes marketed on their website. At least they did, I don't know, a year or two ago. I don't know where it stands. That's the only time I've seen anyone pitch that, propose that idea in Filament. But we have watched some fun winding videos to see that it's a very different kind of machine motion, obviously, that like creates that kind of winding. I also do think that the Stratasys, I want to say some Stratasys spools like unwind like that from the core rather than from the outside.
Yeah.
Yeah.
Yep.
All right. Let's roll through outros real quick. And like I said, if you guys want to stick around, we can keep the questions coming from the chat and keep discussing. So let's start off with our two guests. Since we started with Proto-Pasta first at the beginning, Sean, let's have you go first for your outro. Tell everybody where they can find you, yourself, and IC3D and buy IC3D products.
All right. Well, I am Sean. I work at IC3D Printers. I am an extrusion operator, and I am the community manager. And we make plastic. We make filament. We also have printing service, an industrial printing service, consulting services, and that's pretty much what we do. And you can find us at IC3Dprinters.com. We make PLA, ABS, and now we make PET-G. And you can also find me on Twitter at Sean at IC3D. And that is that. On to you, Alex.
You got that pitch down.
Thanks, man. I just made it up.
Well done. Nothing like winging it. Yeah, hey, I'm Alex, Proto-Pasta. I'm one of the partners in Proto-Pasta, and I've done everything from making filament to doing helping create the brand image, and I'm the guy behind all the social media. So if you find us on Twitter or Instagram, most of the time that's me. Now sometimes it's Tinkers. Keith helps me out. Um, check out proto-pasta.com. I did just this last week reorganize the presentation on our front page to better differentiate the different finishes, break them up into 5 categories. Also have our composites broken down. Hopefully it all just makes a little more sense without digging. We're working on originally building new and unique materials, and now we're building those into categories and trying to continue to grow up, more employees, more products, and just trying to make premium plastic filament for you to have a good experience with in 3D printing.
All right, thanks, Alex. Dave.
Hey, David Randolph over at Printed Solid, and of course Maker Box as well. And of course, it's always fun to kind of hang out with these guys because we sell their stuff over there. Find us on all social media stuff. Wanted to tell everyone that we're having Joel come by. So Joe Telling will be coming over to our shop on Saturday, November 10th, around 6:30. So you got plenty of time to deal with the cheerleading tryouts and all that stuff, and then make your way over and stop on by and have some fun.
Cool. Thanks, Dave. Richard.
Hello, I'm Richard Murray with the Zadim channel. You can find me at zadim.com or Zadim17 social media. The information is on there. I try to focus on 3D printing for model trains, but lately I've gotten into game tiles. I've been plugging away, making a doorway right now. And I try to go live every Wednesday at 4 p.m. Pacific.
Cool. And I'm Matt from the How I Do It YouTube channel and the organizer of the Friday night hangouts. Just some, for my stuff, you can find me youtube.com/howidoit and on Twitter @CountryCowboy. If you would like to follow the Friday night streams on Twitter, it's @F3DPCH. And on Facebook, there is a F3DPCH-public group and an F3DPCH streamers group. The public group is where we just post the events. You can ask questions ahead of time. If there's questions asked there, I will try to make sure that those questions get asked on the stream and answered. The streamers group is if you would like to be a co-host and be on the panel. That's where we do the behind the scenes discussion of the stream coming up and kind of the pre-planning. The next stream is going to be November 9th, which is the European stream. The topic has not been picked for that yet. And this week, Martin will not be hosting. He's going to be out of town. So it will be one of the other European co-hosts, or possibly Richard. Richard joined last week and may join again this coming week. The next US stream is on November 16th at 10 p.m. Eastern. Now, the time this weekend is daylight savings time change for those of us in the United States. We're going to be falling back an hour, so the stream will still be 10 p.m.
Sorry.
I'll try to no problem, Alex. I'll try to post on Twitter leading up to that one, the UTC times and everything, to try to help everybody who doesn't observe daylight saving adjust to the time change for us.
Or
that topic,
instead of a reminder.
What was that?
Or subscribe instead of reminder.
Exactly.
You
can subscribe and ring the bell, and you'll get notified of all the upcoming streams. And we do try to do bumper videos leading up to the stream a few days in advance. Unfortunately, I didn't get a chance this week. It was work. The November 16th stream is going to be Matt Gordon from Printed Solid is going to come on and talk about specific use cases for different types of material and answer questions where one material may be better suited for an application than another material. So that's November 16th. And we've got some other ones in the works that I am super excited about. But for now, until a date's nailed down, I don't want to announce yet. But we've got some outside 3D printing YouTube content creators that a lot of people may know that are going to be coming on who are considering 3D printing for their shop and projects that they do. Right now, it's just a consideration. So they're going to come on and talk about the outside perspective of it. So that's everything we got. If you guys, Alex, Sean, if you guys want to stick around after the 2-hour mark, it's a free-for-all. We try to stay on topic for the first 2 hours. If you guys want to continue to stay on topic, we can. If there's something else you want to talk about, we can talk about anything. Or if you got to go, you got to go.
Got a request. I think it came up, about a year ago. We're talking about getting kids into 3D printing. And the one filament we're looking for that we thought that would just blow the kids over is if we could have an eraser filament. So I know when my daughter was going to school, the number one thing in the book sales was buying all these little types of different erasers. So that's on the wish list.
That'd be cool.
So, yeah, print these out, put them on a pencil, you got an eraser. Now you can make them custom. Yeah,
that's a good idea.
So
there you go, Alex.
I won't. It's been a couple of years, but at one point we were talking about making 3D printable crayons. So it's a wax filament. So given the right day.
TPU with small amounts of abrasive. That sounds great for erasing something permanently, but horrible for the nozzle.
Right. Well, everybody's got rubies now, so it's no problem.
Right? Right. Yeah.
Good night, Ashley S. And hello, Ashley S.
I'm not seeing any more questions from the chat. If there is any more questions that anybody in the chat has that haven't been answered yet, go ahead and post them again, and we'll try to get those questions answered. I did have a question that I wanted to ask during the first 2 hours, and we had enough discussion. I never got to ask it. So, Alex, from Proto-Pasta's products, and this is probably going to be a hard one to answer. What is your favorite thing that you've seen somebody print with Proto-Pasta's products? Is there anything that comes to mind? Or a couple things for that matter?
Well, I mean, I'm a pretty big fan of Guy Snover, who prints a lot of different lighting fixtures and such up in Quebec with our HTPLA product. He heat treats it so that it holds form to the higher temperatures with the lighting, and just makes a lot of beautiful things. He makes his own deltas, and then he does the design in Grasshopper, and then outputs the G code directly from it to do a single nozzle spiral vase kind of deal, and with a texture of the extruding process too. So it's I don't know, it's pretty cool stuff. Also, another one of my favorite prints that I've had one given to me from one of our customers is a guy who does aftermarket BMW cup holders for E30 BMWs, and he's built many of them out of the HTPLA carbon fiber. He treats them again for car interiors, and uses both the combination of the finish and the heat treating to create high-end aftermarket car parts. So those are a couple cool. I'd love to see more and more applications like that where beautiful both function and beauty matter, in the end application.
All right. What about you, Sean? What's something you've seen that comes to mind as a favorite item that somebody's printed with IC3D?
A Lamborghini, like a full scale, like a real Lamborghini.
Really?
Yeah. So we did, yeah.
Okay,
so
that's
we worked
cool.
on this project, and the guy made a Lamborghini. I don't know how to explain. It's a Lamborghini, guys. Like you can drive it. Like, it's real cool. So a lot of the interior parts, a lot of the exterior parts was printed in our ABS, and I think some PET G. It was mostly ABS. But yeah, it's real cool.
That's huge.
It's yeah, you can drive it. It's a Lamborghini. it's massive. So I think that is the coolest thing that happened. But
No, I think that wins. Yeah, and
Yeah, I definitely feel one upped on that.
I
Yeah.
was saying that's the coolest thing I've seen.
This is one of those lighting fixture things, though. It's got this cool design.
So the light bulb goes in. Is that open on the bottom? Okay.
Goes in with a fixture.
Oh, cool.
And that's made with our pine filament. But it's no Lamborghini. I'm you know.
But the important thing, and this might make it better than.
I'm sorry, I didn't mean to do.
When the light's in it and it warms up, does it still smell like pine?
That's a good question. It should.
It would make sense if it does. I wasn't sure if heat treating would kind of like seal.
You can smell the heat treating. You can smell like the odors again. That was the cool thing with coffee. And I mean, I can't say I've heat treated pine. So, but that pine is heat treated though. It's more opaque. Yeah. Anyway.
I'm just checking the chat. Richard,
still no Lamborghini.
Still not a Lamborghini. Richard and Dave, do you guys have any other questions for IC3D or Proto-Pasta or about the 3D printing or 3D filament manufacturing process?
This is the coolest thing I've printed with Proto-Pasta. My beard saver for my CR10, so my beard doesn't get stuck in the gear.
I haven't had that problem.
Well, I have an issue with getting my face close to the bed.
No, I just think filament
I haven't
advanced so well. That's nice.
What was that, Richard?
I was just thinking overall filament is made great leaps forward in the last several years, and it's nice seeing what's on the market. And yeah, Proto-Pasta with the specialty stuff. Yeah, I got some of that on the shelf here, and you make sure everything's really good and running before you put that stuff in. But then people get blown away by what you can do with these printers. At the other end, I have this super cheap stuff in here that snaps on me from time to time, and that's fine for prototyping, but I won't do anything I want to keep for a long time with it. So
Proto-Pasta is like the Gucci of the 3D world.
Yeah.
Like you guys are like Versace, right? Like, I mean, that's what it is. That's what it's become.
It is funny. When I got into 3D printing, the first printer I bought was so that I could make functional parts for projects. And I specifically told my wife, yeah, there's this pasta filament, as I'm telling her about the different things, the different types of filament and everything. It's like, yeah, there's this pasta filament. And I said, I don't see that I'll ever use that stuff. And now I've got, there's probably a dozen or more rolls over there of each different kind. And it's like, I learned pretty early on when I think I got a sample of it from MakerBox, and I've been buying the Proto-Pasta stuff ever since for specific use cases. But it's funny because I remember telling her, yeah, there's no way I'm ever going to spend that amount of money on filament. I'm buying $15 rolls and $20 rolls.
I mean, honestly, personally, me as Sean, in real life, I buy a shitload of. Oh, I'm sorry, I can't say that. I buy a booty load of Proto-Pasta, and I use it to make swatches for painting, like for mood swatches. So I will think of a painting or whatever I want to do, and then I'll print out swatches of Proto-Pasta stuff just to create a mood so I can choose my paint tones according to Proto-Pasta filament. And that's what I do with it mostly. I don't actually print with it. I just print squares.
You just like the colors.
You
like my texture.
It's inspiring. Yeah, it's inspiring. It's beautiful. It's gorgeous. And I mean, it's awesome. I mean, it is what it is. It's something,
and it's still less expensive than some filaments. I'm just gonna say.
And it's still less expensive.
And Genlux.
And I just print squares with it. So I mean,
I'm just saying, Sean, you've been sucking up to Proto-Pasta all night. Are you trying to get a job there, or what's the deal?
No. Sean doesn't get jobs at Proto-Pasta. Sean gets jobs. Sean gets jobs at Prusa. No, that's a shame. You said I'd talk in third person, so I did.
Oh, yeah, of course. You know, the funny thing I always tell people is that I say, you know what? Go out and buy a $12 roll of filament, and then just buy one Proto-Pasta, buy one IC3D, buy one of the higher end filaments out there. Yep. And find out for yourself why there's a difference. And it's amazing. I mean, it's amazing.
Or better yet, buy Maker Box so that you can try all those without buying a whole spool, right? Just saying.
There you go.
Now he's helping with my marketing. All right. But
we're all here to help each other out.
Yeah. It's one of those things is that I see way too many people that go, I never spent above $14 for a roll of filament. And that's their entire criteria. And it's amazing how different filaments actually can be down the road. I mean, Proto-Pasta is not just sparkles and coffee. And I think that's a big thing a lot of people got to get past. And IC3D is not just an expensive version of Hatchbox. You know, there's a lot more to the quality of the materials, and I think people miss out on that a lot.
There's a lot of different levels of expectation of 3D printing based on like maybe budget or like your circle where your information comes from, your experience, and what one person considers like a good high quality print versus another can be like shockingly different. Based, like a lot of folks I think sell themselves short on what 3D printing's capable of based on their experience. They'll be like, oh, like, this is all that is all that's possible when so much more could be.
That's why I love it when I get the people that have, the cheap little model pictures and they walk in the store and see the prints we have there and the materials. And it's like they just discovered a whole different industry.
Right.
Well, it's with Printed Solid releasing Sir Layers a lot in the last week. It's funny to watch the pictures pop up on Facebook and on Twitter because there are prints that, I mean, they deserve the praise that they're getting on how awesome that model is and how well that person printed it. And then there's other people who are absolutely thrilled with the quality of their print of Sir Layers a lot. And I look at the picture and I'm like, I remember those days. I remember when I thought that was cool as hell. And now I know what my printers are capable of as I got better with the technology. It is interesting to watch what people do consider good versus what really is achievable from a printer.
Right.
When we commission Sir Layers a lot, and we kept working with them to try and get the design right. It was sad, the things that we kind of had to be like, can we move this over? Can we simplify this? Because we know there's people out there that just don't know what they're doing.
Yep.
And try to hide, parts so that when it is good print, it actually comes off as a good print. But if people, do a crappy print, it technically looks like a knight and not a glob.
Yeah.
There is one part on Sir Layers a lot that, if you look close enough, prevents you from printing them with 0 infill, which is where the hand meets the shield. There's a little bit of a divot there. I filled mine in with super glue. I put the XTC 3D on, let it set up till it was like just enough that you could touch it without getting a fingerprint, and poured a bunch of super glue in on top of it and hit it with some activator.
You're right. I never noticed that.
There's all sorts of little overhangs on it. There's 0 infill questions. There's layers. The cape has a lot of secrets on it. If you look at the cape on how it actually meets the bed surface, that's entirely to tell you about your layer height and Z-wobble problems.
Yep.
Okay, I got the current record holder here. What are you talking about?
Oh, there it is.
The slope of the cape will tell you if you've got any Z-wobble. It's going to tell you what your layer height's set to. There's a lot of cute little details in there that we kept trying to push into that.
And for anybody who hasn't seen it, now this is 390 millimeters, and it's already sanded and coated with XTC 3D. But that's
what material?
Sir Layers a lot. That's
very shiny.
Printed solid daily white.
It's what?
Cardboard. It was only appropriate.
Does the XTC have a tint to it?
It does not. So it's white. I sanded it and hit it with primer and then put XTC 3D
on.
I like to sand and primer it before I put the XTC 3D on.
I was thinking the same thing. I was like, that's not white.
Yeah.
I know it's getting late, but...
By the way, have you looked at the symbol on the shield? Do you know what that is?
I don't. What is that? It looks familiar, but what is it?
That's the little robot from the Printed Solid logo.
Nice.
Very slick.
And stylized to look like a shield.
Now that you say
that, you guys put a lot of thought in that. That's cool. It's fun. Little hidden things.
I sat around for 3 months thinking about everything I wanted in it, and then we got it, commissioned and done in like 2 weeks.
Wow.
But I was like, I want
a good turnaround, man.
This reason I had reference photos and everything just for that sucker.
I will tell you, I'm glad you guys released it with the Creative Commons license that you did, because I am going to remix it. My daughter's school mascot, they're the Golden Knights. And I'm going to be, no offense, I'm going to be taking the Printed Solid off and doing a custom one for my daughter's elementary school.
Oh, come on, hide the logo somewhere.
This is I'll put it on.
Dude, just put it at the bottom.
Put it on the bottom.
Even though this is a live stream, don't tell anybody that I said that.
But I don't blame you. And you see there's already, a couple of remixes out there, the Grumpy Pumpkin and the Skeleton Head and all that stuff.
Yep. Yeah, you guys did you did the Grumpy Pumpkin one.
Oh, right. Matt was all over the Grumpy Pumpkin. He wanted to do something with Grumpy Pumpkin. And that was like overnight, had to. I want somebody to design a horse for him.
Yeah. Did Carl do the Country 3D one? I see he posted it, and the water version is awesome in the chat, but he's the one who did the remix and put Walter's head on it, eh? Which I did like the fact that it looks like the mask is lifted up. I don't know if that was his hat or if he actually tilted the shield.
I think he ripped off if I remember right, I think he ripped off the shield and put a hat on top.
Did he? I didn't get to look real close at it, but I did see it the other day when I pulled the STL down again.
And by the way, when we sized it, it's default size when you download it. It's just under 50 grams if you print it, so it just works perfectly with MakerBox sample sizes.
Why would you want to do that?
And then it fits great in the bags that all the MakerBox samples come with. Just saying.
That's awesome.
That's actually kind of neat. The default size is 100 millimeters, right?
That's correct.
Okay.
100 millimeters, 45 grams.
I had to print 100 millimeter ones for my daughters after they saw that one. They each wanted one. So my 2-year-old and my 6-year-old. Let's see. I'm not seeing any more questions in the chat. Dave or Richard, did you guys have any more questions?
No, I think we've covered a great deal of it. It definitely, when you get into 3D printing, you get a lot of people going, "Oh, I'm going to extrude my own filament." And the more you learn, you go, "No, not a chance." Glad you folks are doing it.
Thank you.
Yeah, we'll take the pain for you.
Yeah, any day.
Is there anything else you guys, either one of you, just want to share about the process, or anything else you guys want to talk about tonight?
Yeah, I've really enjoyed the experience, but I'm just thinking about sleeping before having a workshop tomorrow.
Yeah, there actually, that reminds me, there was one question. When's the next workshop? And I'm assuming I was a smart ass in the chat and answered tomorrow. But
Right.
do you guys have another one planned after this one?
Tentatively February, I believe, but we didn't pick a date yet.
Okay.
So we're gonna go with quarterly cadence for the moment and see how things develop. This is only number 2, but it's not a small thing to do, and so we thought, hey, let's start with quarterly cadence.
Now you guys just need a portable extrusion line so that you can travel around the country and do remote filament shops. I don't know if I'm ever going to get out to Seattle to be able to do it, but that would be awesome.
Go extrude in Tahiti.
There you go.
Yeah. I think we've got a lot of really important customers in Hawaii. I don't know. I'm just saying.
All right. Well, if nobody has anything else, I'd like to thank Sean and Alex for coming on, and I apologize to Keith. He dropped off. I didn't really get to ask him questions about what he does at Proto-Pasta and everything, but thank you to the 3 of you for coming on. And you guys are more than welcome to come back on any of the streams. It doesn't have to be filament related. You're more than welcome to join in anytime you guys want to. So,
awesome. It was a lot of fun. Thanks, everybody.
Look after yourself.
Thanks, Richard, and thanks, Dave, for coming on and helping ask questions and keep the conversation flowing. And we'll see you guys again for the US stream in 2 weeks, or you can catch the EU stream a little bit earlier in the afternoon next Friday on, I keep forgetting the date, sorry, on the 9th. So thanks, everybody. Have a good night.
Have a good night, all.
Good night, everybody.